A single question opens the story. What does it mean to imagine a world with no borders, no oceans to separate continents, no archipelagos of nations, only one land, unbroken and immense? That question sits like a stone dropped into a well, ripples of thought spread outward, catching on scales of time and space that make human lives feel brief and fragile. It is an image and a provocation. Once, the continents seen on every map today were not islands on a scattered sea, but parts of one colossal entity, Pangea. How did that unity shape the Earth, and what, in the slow, inexorable choreography of the planet, tore it apart? The voice of the narrative does not begin with geologic minutiae or with a catalogue of dates. It begins with the mind's eye trying to hold a shape. Pangea is not a simple landmass. It is a proposition about scale. Imagine a single continent so vast that it folds climate into new behaviors, so large that an interior can feel like an island within an island, far from any ocean breeze, vast enough to host deserts that are not just local phenomena but continental heartlands. Imagine mountain chains stitched across its seams, rivers that starved before ever reaching a sea, and a coastline so long in few places that entire weather systems were born and died along its edges. The idea arrests the imagination because it forces modern humans, the descendants of latecomers in Earth's long story, to compare their maps with a deeper, stranger geography. To speak of Pangea is to speak in superlatives, the land that gathered. It assembled during a convulsive era when the slow drift of plates, invisible by day, carved pathways for continents to collide and merge. The continents that would later be split into recognizable shapes: Africa, South America, North America, Eurasia, Antarctica. Australia approached each other over tens of millions of years. Where they met, mountain belts rose like seams, folded and refolded by crustal pain and pressure, leaving scars that would later be worn but never wholly erased. In some places, the union produced ranges that were the grandparents of modern mountains. In others, it pressed ocean floors up to form inland seas and basins. The unity of land reshaped winds, moisture, and the ecology of life itself. The narration stretches across that landscape not as a fixed map, but as a living system. The ocean that surrounded Pangea Panthalassa was not merely a backdrop. It functioned as a mantle of cold and warmth, shaping currents that circled the supercontinent. Between land and sea lay the Tethys, a narrower, shifting sea that threaded through the seams of Pangea like a scar that would never fully heal. Those waters were broad enough to cradle their own ecosystems and yet intimate in scale compared to the vast Panthalassa. Where coastline met ocean, stones could gather with relentless force, slamming into a shore that, in many places, recessed only rarely into embayments. But in the heart of Pangea, far from those salt waters, the climate took on extremes. Rainfall patterns became continental in scale. Monsoons slammed continents from the edges inward. Dry seasons lengthened into arid ages, and temperatures swung across seasons in ways that would challenge life forms adapted to narrower bands. There is an emotional rhythm to this geological description. The narrator leans into contrasts, closeness and alienation, abundance and scarcity, the intimacy of a shoreline and the sterility of an inner desert. The interior of Pangea could be vast and unforgiving, a place where rivers, mighty in their own right, might start with promise and then peter into salt flats, unable to find an ocean. The psychological weight of such a place is not unlike reading a map, with entire regions designated as blank, not because they held no history, but because their history is written in stone and silence. The mind responds with a mix of awe and a faint unease. This was not an environment of small niches, but of continental-scale experiments in climate and life. Inventory of life invites a different kind of wonder. The epic of Pangea overlapped with eras of life that modern observers recognize only as fossils in textbooks and museums. Ferns and cycads and conifers painted the land in shades of green that would, to eyes untrained in geologic time, look both familiar and utterly foreign. The early occupants of this world were not hominids but creatures whose bodies were shaped by very different rules. Reptiles that would give rise to dinosaurs, synapsids, and amphibians that dominated wetlands. Insects the size of birds in certain eras where oxygen content allowed such excess. Forests sometimes rose into cathedral canopies. In other places, stretches of low-lying marshes became peatlands and later coal seams. Their buried remains the economic bedrock of human industrial ages millions of years hence. The narrative does not catalogue species so much as it gestures toward the texture of ecosystems. The way sunlight filtered through dense cycads, the hush of a conifer stand on a cool Permian morning, the thunder of a herd, not in human terms, but in the terms of biomass and movement across a land that felt continuous underfoot. The voice then shifts into tectonic theater. The forces that assembled Pangea were patient and merciless. Imagine the continuity of plates sliding and colliding over geologic time. Oceans shrinking as continents approached, subduction zones swallowing ocean crust with the indifference of a slow machine, continental collisions buckling crust into ranges. That slow violence painted the planet in a way the human conflict on a daily scale cannot match. Yet the eventual unraveling of Pangea was not an overnight drama, but a protracted drama of strain and fracture. Rifts began as small, almost imperceptible cracks, lines of weakness where the mantle below thinned and heated. Rivers of magma, invisible at first, rose and pooled. Volcanoes fed newly forming basins. Sea floors opened where cracks widened into rifts. It was the geological equivalent of a seam being pulled carefully by an invisible hand until the fabric gave way. The breakup, when it came, was messy and creative. New oceans formed where there had once been land connections. Ha! The Atlantic began to open as a slender seam, widening with time into the century-long ocean it is today. Africa and South America drifted apart, and with them went climatic continuities, plains that once shared a common fate now found themselves in different weather regimes, subjected to different storms, new currents, and different evolutionary pressures. The narration lingers on this process because it is at once technical and poetic, the physics of plate tectonics intersecting with the biological consequences for life. Species that once roamed a coherent land were suddenly isolated, and their descendants would evolve along divergent paths, creating the biodiversity patterns that modern scientists try to unravel in samples and sequences. There is a melancholy embedded in that separation, and nay, the piece speaks of loss without human voices. Loss here is not sentimental but temporal, the loss of continuities that had developed over epochs, the disappearance of climatic regimes that allowed certain forms of life to flourish. The narrator uses this melancholy as a lens through which to frame a larger mystery. What traces remain of Pangea beyond the rocks? When plates shift and seas enter, what happens to the record? Rocks are rearranged, uplifted, eroded, swallowed by later seas. Some features endure: mountain cores, cratons, zircon crystals older than most known life, but much becomes palimpsest, overwritten by later epochs. This leads, inevitably, to a more provocative question that bridges science and speculative thought. What could have existed in those lost continuities that now lies buried, broken, or erased? The voice remains careful. It does not invent hidden civilizations or contrive specific tales. Instead, it invites contemplation about possibilities inherent to deep time. Geological processes can erase, yes, they can also preserve in unexpected ways. The same coal seams that feed modern furnaces were once living ecosystems. Limestone beds are archives of ancient seas. Fossils tell partial stories, fragments of lives, hints of behaviors, conjectures about diet and movement. Yet gaps remain, and in those gaps the human imagination tends to wander. Speculation is treated as an intellectual exercise rather than a claim. The piece suggests that if imagination is constrained by what the rocks currently show, then conversely, the absence of evidence in some places compels more creative forms of inquiry. Could a culture, had it arisen during a remote window in deep time, leave traces that are now indistinguishable from geology? A terrace carved in stone, perhaps reworked into a cliff face by later tides? Would a monument of some sort survive the grinding teeth of time and plate motion? These are not assertions, but questions folded into the narrative to provoke a particular feeling, the feeling that the geological record is at once generous and miserly, generous in the scale of what it preserves, and miserly in the specificity of what it allows us to read. The tone tightens into a philosophical reflection. Pangea, as a concept, reframes human chronology. A city that lasts 1,000 years seems monumental to modern society. It is an instant against the clock of plate tectonics. The narrative invites listeners to feel the vertigo of that comparison. It asks them to imagine walking the length of a continent that would, in a few geological breaths, become many. It frames humanity's present as a brief flare on a planet that has time to weld continents, raise mountains, and drown them again. That sense of smallness is deliberate. It is not meant to belittle, but to humble, to reposition human anxieties in the context of a living earth whose rhythms are deeper and stranger than daily headlines. Yet Pangea is also a story about contingency. The assembly and breakup of continents are not just processes, but events that set probabilities in motion. When a continent splits, migration pathways disappear. When seas open, currents reorganize. These shifts alter the course of evolution, of climate, of chemistry, in ways that ripple for tens of millions of years. The narrative frames each tectonic shift as a fork in a story whose protagonists are not humans but life forms, climates, and the oceans themselves. In this light, Pangea becomes not merely a backdrop, but the very context of possibility, an actor in its own right. Small scenes are expanded into larger contemplations to keep the audience engaged. The piece spends time on specific micro-narratives that are actually macro-ideas. The inland basin that once hosted a chain of lakes, and then, as the climate shifted, dried into a salt flat, the coastline where an ancient storm left patterns in sediment that survive as ripples in stone. A volcanic province that bled ash across thousands of kilometers, altering sunlight and climate and triggering biological turnovers. Each vignette becomes an access point into the larger theme of continuity and rupture. They are meant to be cinematic moments in a documentary narration, concise yet laden with implication. Throughout, the voice remains third-person, omniscient, a guide that both knows and wonders. It never becomes prescriptive. It presents Pangea as a subject for reflection. The occasional technical anchor dates measured in millions of years. Names like Panthalassa and Tethys serves to ground the speculation in recognizable science. But the style always returns to the meditational, the sense of awe at scale, the poignancy of loss, the curiosity about what lies in the deep dark of geological ignorance. The final texture of this opening is ambivalent but resolved. On the one hand, Pangea is history, evidence, and calculation. Explain its existence and demise. On the other hand, it is a narrative space where questions multiply. How did climate operate across that unified land? What ecological experiments unfolded in its interior deserts, in its shorelines, along mountain ranges that forged rain shadows, and, in the quietest of whispers, what if some aspects of that ancient world, some artifacts of possibility still lie hidden, waiting to be read by fingers that know how to read stone? The narrator closes this part of the story with a soft insistence on curiosity. The separation of continents did not erase every trace of Pangea, but it did complicate the search for continuity. The past is not a closed book, it is a palimpsest. In the layers of rock are pages written, erased, overwritten, blurred. To read them requires more than science alone. It demands an imaginative humility and a readiness to accept that the earth is both generous and secretive. The opening moment leaves the listener with the image of a single, enormous continent, a world simultaneously intimate and alien, and with the unsettling, irresistible question that will guide the narrative. What did that world look like? And what, in the slow machinery of the planet, finally broke it apart? What does it mean? In the slow arithmetic of Earth, for great pieces of rock to decide, over errors to meet, the question hovers like a thin breath before a mountain-forming storm, not a literal choice, but a sequence of inevitabilities, densities and flows, colder slabs sinking, buoyant crust rising, that conspire to bring continents together. Around 335 million years ago, those inevitabilities resolved into an event so vast that it reshaped the planet's politics of climate and life. The continents, thought of now as separate and finite, approached each other and knit into a single unimaginable whole, Pangea. It was a landmass so complete that its edges became the only edges. Around it stretched one ocean without rival, Panthalassa, a circlet of water that would make the supercontinent feel both isolated and globally exposed. To imagine that collision is to imagine time stretched into a landscape. It is not a single crash, but an accumulation of tiny, relentless displacements. For tens of millions of years the plates grumbled, sinking here, bulging there, until the seams between them closed. The geological vocabulary for such events is clinical, convergence, subduction, suturing, but the effect was anything but dry. Where continents met, crust folded like thick cloth pushed through a slot. The seams became mountain belts, ranges of rock forced upward, valleys buckled into basins. These were not cheerful hills, but the bruised, folded scars of a planet working itself into a new configuration. On maps this process is tidy, lines and labels. In landscape and weather it was theatrical. Imagine a chain of ranges kilometers high that carried snow at their crowns, dripping meltwater into rivers whose courses would be decided by new gradients. Imagine the collision zones, what geologists later called sutures, filled with smashed fragments of ocean floor. ophiolites wedged into continental crust, a kind of tectonic collage that told of one ocean's slow death as land took over. These were places where the Earth's deep machinery made its presence visible, and where the chemistry of air and soil began to change in response to pressure and heat. Panthalassa was the planet's constant partner in this drama. To the people of this speculative story, the listeners imagining deep time, Panthalassa is both a name and a mood. The great surrounding ocean, vast and continuous, its currents running in long, unbroken gyres that cared little for the seams stitched on its margins. Surrounding a single supercontinent, such an ocean would exert different influences than the segmented seas of the modern world. Without the interruptions of archipelagos and narrow straits, oceanic currents could sweep uninterrupted, drawing and redistributing heat in patterns that made the coastlines of Pangea into critical, fragile places. Storms traveling across Panthalassa would strike the single rim of land with unshown continuity, generating weather systems that could, in some seasons, wrap half the continent in a single climatic gesture. Within Pangea itself, the interior developed a character distinct from the edges. Size breeds extremes. The vast stretch of land removed from marine moisture became a stage for weather of continental proportions. Monsoon systems that, in some epochs, might have driven wind and rains far inland and in others left great swaths of central ground parched. In many reconstructions of this time, the heart of Pangea resembled an enormous basin that sometimes held lakes, sometimes salt plains, sometimes river systems that never quite found the sea. Rivers, born in youthful mounds, could travel hundreds of kilometers only to end in marshes and playas. The idea provokes a strange melancholy. Rivers deny their ultimate destination, taking their sediments and histories nowhere, the way a story that is begun and never completed feels unresolved. This intermediate world, neither wholly coastal nor oceanic, meant that ecosystems here evolved under different constraints. The species that thrived at the edge of Panthalassa found the temperate, marine-tinged airs of the rim familiar, but inward, the flora and fauna had to adapt to broader swings in temperature and moisture. Forests at the margin might be lush and humid, cathedral-like, with towering conifers and undergrowth of ancient ferns. Deeper within, cycads and seed ferns adapted to drought, creating landscapes of strange, dense, low-lying vegetation, punctuated by stands of trees that, to a human imagination, might seem both alien and eerily familiar. The patchwork of life, coal-forming swamps, drought-hardened scrublands, marshes, was a laboratory of evolutionary experiments, each held together by the steady rhythm of seasons stretched across continental space. The assembly of Pangea carried with it an emotional cadence that the narrator cannot ignore, an awe at scale, and a quiet apprehension at the hidden violence of creation. Mountain chains born of collision would cast fast rain shadows, leaving leeward interiors dry. The same orogenic force that produced grandeur also produced deserts. In some corridors where ranges pressed close, winds funneled into violent gusts, carrying sand and ash to be trapped in valleys that later lithified into telltale layers. Over time, these layers served as geological diaries, paleostratigraphic pages that tell where water once lay and where it withdrew. Tethys, the other oceanic presence, played a different role. Not the vast encirclement of Panthalassa. Tethys threaded through the seams of the supercontinent like an inland sea, changing shape as continents sutured and rearranged. It was part scar, part corridor, at times a broad marine environment able to cradle unique ecosystems. At other moments, a narrowing set of straits that redirected currents and constrained migration. Where Tethys reached into the land, coastal shelves collected life, and those collections would eventually be recorded in limestones and shelly beds, mineral pages that preserve chemical signatures of an environment's warmth, salinity, and productivity. The narrative does not stop at physical description. It expands into sequences, scenes in which the geological processes become nearly cinematic, each expanded into a fuller vignette that invites both awe and reflection. Scene 1. The rise of the ridges. For a million years, an easy unit in geological storytelling. Ocean lithosphere slid beneath. Continental margins. Subduction zones became the planet's slow, hidden machines, pulling old sea floor into the mantle and inviting continental fragments to meet. In the places where two continental plates finally collided, the crust had nowhere to go but up. Imagine, over tens of thousands of human lifetimes, ranges climbing into the sky, rock layers folded, overturned, and then uplifted until they started to intercept weather in ways they never had before. Snow collected at high altitudes, feeding rivers that carved into younger rock. The soundscape here would have been one of persistent but low-grade geological noise, rumbles of landslides, the subtle music of streams cutting canyons, the occasional eruption when mantle upwelling breached the surface. The emotional tone is not triumph, but inevitability, the planet remolding itself, indifferent to whatever life exists upon it. Scene 2, the inland basin that died twice. In the shadow of the new mountains, a basin formed. For a while it was generous. Lakes stretched across its floor, fed by meltwater and monsoon rains. Sediments accumulated, life thrived in the shallow margins. Algae swam in green-rich waters, amphibian ancestors nested in reeds, arthropods scuttled amid the muck. Over epochs climate shifted. Winds carrying desiccating heat crept further inland. The lakes contracted into a chain, then into salt pans. Mineral crusts formed. Where once there had been a chorus of croaks, they became the hush of cracking mud. The basin recorded both phases in layered strata, shales of freshwater life followed by evaporites, then wind-blown sands. The narrator lingered here because the scene captures a human-like pathos, a place of promise muted into silence, then reborn perhaps in an entirely different climate regime later. It is a microcosm of geological cycles of abundance and scarcity. Scene 3, the storm coast. On the western rim, Panthalassa sent storms that were oceans in motion. Hurricane-scale systems, though not identical to modern hurricanes, gathered momentum over the long-standing expanse of water and struck the rim with a relentless rhythm. Their effect was to sculpt coastlines. Cliffs eroded into arches, embayments deepened, sediment plumes flowed into the sea, and offshore fans collected the sound of entire seasons. In the rock record, such storms leave recognizably violent signatures. Graded beds of mixed debris, rip-up clasts where peat was torn loose and transported, layers of sand lenses deposited under tempest ice. Listening imaginatively to such a coast is to hear an elemental percussion, waves and wind as the planet's own percussion section, marking time at a rhythm foreign to human calendars. Scene 4, the volcanic breath that changed the sky. Tectonic activity did not merely raise mountains, it punctured the atmosphere. Plumes of magma rose from the deep, creating flood basalts and volcanic provinces that blanketed regions in ash and lava. These events could be brutally consequential. Aerosols in the upper atmosphere dimmed sunlight, causing temperature shifts that stressed ecosystems adapted to prior conditions. In the record, such pulses show as layers of tuff and ash, and wherever they coincide with turnover and faunal assemblages, scientists read the handwriting of catastrophe. The narrator is careful to call these not moral moments, but causal ones. The planet altered climate chemistry, and life adjusted, sometimes with extinction, sometimes with surprising new radiations. Each expanded vignette is anchored to geology, but refracted to an ethical palette that is not moralizing. The emotional arc is subtle, from the wonder at scale to an awareness of violence that is as necessary as it is indifferent, to a sober curiosity about what will endure. The question of endurance pulls the narrative into speculation, but always framed as questions rather than assertions. What kinds of traces might survive such tectonic upheavals? Rocks preserve many things: chemistry, mineralogy, the shapes of sedimentary ripples, but the specificity of civilization, of intentional marking, is a far more complicated thing to imagine surviving the slow chew of plate tectonics and erosion. The narrator asks whether any constructed pattern could be read back as construction rather than as geologic happenstance. Could a terrace cut into bedrock, for instance, be interpreted with certainty as anthropogenic if it had been exhumed and reworked by tides and sediments for countless ages? The point is not to claim hidden histories, but to insist on humility. The geological record is both generous in scale and miserly in detail. It saves contours and broad stories, but the precise seams of social life, if they ever existed in deep time, could be smudged beyond recognition. That tension between what is preserved and what is irrevocably lost is a quiet yet persistent note across this part of the story. There is also a theme of contingency deeply woven through the assembly of Pangea. The narrator emphasizes that plate motions set probabilities in motion. They do not decide the future in human terms. When a landmass moves, it reconfigures rain paths, changes the chemistry of coastal upwelling, rearranges migration corridors. Such changes ripple outward, altering evolutionary possibilities. Species that would have dispersed along a long, unbroken coastline suddenly face geographic barriers. Others find new corridors formed by mountain ranges eroding into basins. The narrator invokes this to remind listeners that Earth's history is a history of forks, events that amplify some outcomes and silence others. As the part winds toward an ending, the voice draws one last image, a cartographic exercise in patience. Picture a single sheet of paper representing Pangea. On that page, mapmakers might annotate mountain chains, sea inlets, basins, and rivers. Now imagine the paper being gradually cut and each fragment slipping away, folded, and then reprinted on other pages. The shapes remain, but their relationships have changed. Fossils, rock signatures, and mineral ages provide the clues that allow modern geologists to reassemble the quilt. They can recognize the seams in the patterns of rock and the echoes of glacier striations or coal seams that once lay contiguous. Yet between those seams lies the great space of ignorance, the details of weather patterns, the full richness of life forms in particular basins, the occasional catastrophes that left only chemical traces. The formation of Pangea is thus presented not as a solved problem, but as a meditation. It invites listeners to consider scale, the slowness of plates grinding and the immense consequences of their movement, and to feel small, temporarily alive on the skin of a planet that can and does remake itself. It asks the audience to hold two images at once: the clarity of scientific reconstruction with its dates and orogenies and named seas, and the fog of things erased or blurred by time. In that tension, curiosity finds its angle, an energy to look deeper, to read stratigraphy as narrative, to imagine climates as characters in a drama where life is constantly being asked to adapt. The narrator leaves the scene with a subdued insistence on wonder. Pangea was a real, heavy thing, a continent that gathered and reshaped possibility across an entire planet. Its formation taught the Earth new habits, new winds, new deserts, new channels for life to flow, and it set a stage that would later be ripped and rearranged. The legacy of that assembly is both in the rocks, which can be read with patience and skill, and in the questions that remain. How did monsoon belts cross a single landmass? How often did interior basins flip from lushness to aridity? What archives of chemistry and structure remain, quiet and waiting in layers yet to be read? Those questions are not footnotes, they are invitations. The assembly of Pangea is less a closed chapter than a door. It opens onto a corridor of inquiry where geophysics, paleoclimatology, and the tactile imagination of the listener converge. To stand on that threshold is to feel the smallness modern life usually hides, a smallness that does not diminish human worth, but that refocuses human curiosity toward what is patient and deep. The supercontinent did not stay together forever. Its time was long in human terms, but finite in geological measure. It left traces across mountain cores, across sedimentary pages, and across the very chemistry of oceans. In those traces lie both knowledge and mysteries, the scaffolding of a story that is at once grand and, in its silences, profoundly human in its invitation to wonder. What would it feel like to stand on a single sheet of land so vast that the horizon itself becomes an argument, an unbroken line? That insists on scale? The question sits at the center of the narration like a compass needle. It points away from familiar maps and toward a geography that rearranged climate, movement, and life. In that thought, the landscape of Pangea unfurls not as a backdrop, but as a protagonist with moods, temperaments, and a stubborn capacity to shape everything that touched it. The first thing to register is the continuity of height. Where once separate continents met, ranges stitched together into mountain belts that traversed what would later be divided into modern nations. These were not isolated reliefs, they were continental spines, chains of uplifted crust that ran for thousands of kilometers, a procession of peaks and ridges that sculpted the entire continent's weather. The image is almost mythic, a spine of the world, a serrated seam where crust had been folded and welded by pressures impossible to imagine on human timescales. Snow and ice collected at the altitudes of these ranges on geological winters, feeding rivers that threaded from the slopes like veins. The very existence of such continuous orogenies meant that rain fell, rivers flowed, and erosion wrote a slow, repetitive music into strata over epochs. Those mountain belts were complex in their interior life. In places, thrust sheets, slabs of rock pushed over younger rocks created surfaces of bewildering geometry. In others, metamorphic cores exposed ancient lithologies, rocks older than many living clades. The surfaces bore scars of repeated glaciations, of streams grinding into canyons, of rockfalls rehearsed over millions of years. The narrator lingers on the feel of such ranges, the dry rasp of wind across high plateaus, the sudden hush of snow-laden passes, the taste of mineral aerosols carried from uplifted basins into turbulent skies. These physical textures become emotional touchstones, an awareness of endurance, of processes that outlast empires and ecosystems alike. Between those spines lay valleys of an almost impossible breadth. Imagine corridors so wide they could cradle entire climates, vast linear depressions that acted as gutters for continental weather. Some of these were foreland basins, places where the crust flexed downward under the weight of mountain belts and filled with sediments delivered by a continent's worth of erosion. Others were rift valleys on a continental scale, where crustal stretching hollowed the land into a trough, a geological scar that later filled with lakes or rivers. These valleys were not gentle folds, but dramatic seams, lowlands that could collect water, heat, and life, then release them in cycles measured in tens of thousands to millions of years. In these valleys, wind found a peculiar voice. Constricted at times by ridges and free at others, it carved patterns in deposits like a slow hand writing in sand. Aeolian sheets accumulated, turned to rock, and preserved the memory of directions and strengths, cross beds tilted like frozen waves. Fine-grained lowest layers that whisper of dust storms, horizons of ripple marks that read like paleographic entries. The valleys also functioned as climatic conduits, channels that funneled monsoonal moisture when prevailing patterns favored wet seasons, and corridors that amplified desiccation when the sun swung toward extremes. Rivers in Pangea were not modest local streams, but super-rivers, arteries that ran for thousands of kilometers, sometimes from high continental cores to coasts that, in the continent's later disassembly, would end up on different modern shorelines. Their courses were dictated by gradients that played out across continental scales, uplift here, subsidence there, the slow tilting of crust as plates flexed. Some rivers began like promises, glacier-fed springs in high passes, and then gathered size as tributaries drained entire mountain belts. They carved canyons that preserved long sequences of sediment, they braided across plains in seasonal abandon, and they bore loads of silt that would someday become deltas of epic proportion. Yet not every river reached the sea. One of the most haunting images the narration returns to is that of the river that dies inland, a waterway that runs energetically for thousands of kilometers and then evaporates into a playa, a salt flat, a chain of ephemeral lakes. There is profound melancholy in a river with no oceanic destination. Sediments deposit, salts concentrate, microbial mats salted to mineral crusts, and in time those deposits lithify, shales, evaporites, and salts that record the story of water receding into silence. The idea resonates beyond geology. It reads like a parable about beginnings that do not reach their intended ends, of large systems truncated by climate and topography. This brings into focus the continent's great climate dichotomy. Pangea did not possess uniform weather. Rather, it arranged climates into a kind of split personality. Around its rim, coastal belts were often green and humid places where proximity to Panthalassa and Tethys brought moisture on prevailing winds. Lush forests thick with conifers, ferns, and cycads clung to these margins. The narrator dwells here on sensory imagery, the smell of resin and damp earth, the shadowed cathedral of towering trunks, the constant sound of insect chorus mixed with distant surf. These coastal belts were ecological engines, places of diversity and abundance, where life could flourish within the buffer of marine influence. Step inland, however, and the mood changes. The sheer extent of the continent produced a vast interior that was starved of oceanic moisture for much of the year. The result was a continental aridity whose scale is difficult to understate. Deserts that were not local anomalies but continental heartlands. Sweeping seas of sand and dried mud that could extend for thousands of kilometers. These interiors were shaped by rain shadows from the mountain belts and by the simple geometry of distance. Moisture that evaporated from the ocean fell on coastal regions. The air that moved inward was often drier still. In some seasons, monsoon systems pushed moisture far inland, causing a greening that might persist for centuries before the climate swung back to long drought. The narrator expands such a transition into a scene of climate theater. A seasonal wind, an immense, slow-breathing monsoon arrives from Panthalassa, bringing weeks of rain that transform parched riverbeds into torrent courses. Vegetation responds with explosive growth. Fungi carpet the forest floor. Ephemeral lakes mirror the sky. Then, as the orbital weather of deep time shifts across tens to hundreds of thousands of years, the monsoon weakens. Rainfall retreats to rim regions. Grasses shrivel, dust storms return, dunes sharpen. The scene captures cycles of abundance and scarcity in grand gestures, each phase leaving its mark in sedimentary language. Coal seams in long-season swamps, then layers of wind-blown sands. Equally dramatic are the forested belts that embroidered the coasts, networks of green that owed their richness to the seas around them. These forests were not monolithic. They hosted gradations from humid, mangrove-like assemblages at low latitudes to cooler, temperate conifer stands higher in latitude. Their ecological complexity meant that they could be places of refuge during harsh interior phases, sources of dispersal when conditions allowed, and sites of evolutionary experimentation. The narrator uses the image of a coastline as a living fringe along which storms carve and rebuild, where estuaries gather life, and where periodic sea level changes wrote new margins into rock. The arboreal and desert halves were not static. Fire, too, was a dynamic agent. Periodic ignitions, whether from lightning in dry seasons or from volcanic pyroclastic. Storms swept across landscapes, creating patterns of burn and recovery. These fire-shaped nutrient cycles opened canopies and drove the evolution of traits in plants and animals alike. Charcoal layers within strata testify to rounds of conflagration separated by epochs, and the narrator suggests listening to those layers as one listens to an old radio signal, crackling evidence that climate and life were linked in feedbacks that could be both creative and destructive. A thread running through these descriptions is the idea of scale, not only in distance but in time, where a human lifetime might record a single flood or drought. Pangea's landscapes registered patterns across glacial, interglacial cycles, volcanic epochs, and the slow cadence of plate uplift and subsidence. Landscapes themselves were palimpsests, each surface a composite of episodes, a braided river deposit capped by a soil horizon, then buried beneath ash from a distant eruption, then scoured by a later flood. To read the land was to read time in layers. The narration expands several of these episodes into longer vignettes to give the listener a sense of life within the immense geography. Vignette: the Great Folded Range, a mountain chain that once bridged what would become distinct continents, lifts its ridges high. For millions of years, snow collects in higher basins. Glaciers grind cirques into stone. Meltwater slips into rivers that assert their persistence by cutting canyons, sometimes kilometers deep. The range acts as gatekeeper. Windward slopes bloom, leeward slopes dry. Valleys beneath the range become repositories for sediments, their fill thick and complex, harboring fossils and chemical signatures that will long be read as the fingerprints of an age of compression. The narrator emphasizes the slow choreography: uplift, erosion, subsidence, burial. It is an iterative sequence in which landscapes are continually renewed, sometimes exposing ancient crustal pieces that reveal the history of continent collisions. Vignette: the super river that never reached the sea. A watercourse fed by snowmelt and monsoonal storms travels vast distances, crossing plains, carving channels, and depositing nutrient-rich levees. For an observer across epochs, its life would seem both robust and tragic. Its terminus, a broad, shallow inland sea, shrinks with climatic drying. The river terminates in mudflats. Salts concentrate. Microbial mats precipitate minerals that entomb organic remains. In the rock record, this translates into an alternation of fluvial sandstones and evaporitic beds, a sequence that tells of water declining in presence but not in impact. The image resonates because it folds in the theme of interrupted connectivity, something that begins with motion and purpose and ends in arrested sedimentary stillness. Vignette: the desert's slow march. In the interior, dunes migrate like slow waves, their crests capturing ephemeral pulses of wind. Vegetation, when it appears, grips in small oases. In certain intervals, dendritic drainage appears. Plants colonize and ephemeral lakes persist for centuries or millennia. Then climate reverts. Dunes overrun soils, lowest blankets older horizons. Over tens of thousands of years, the desert's edge migrates, an advance and recession recorded as alternating soil horizons, paleosols, and wind-blown sands. Here, the narrator dwells on texture, the soft hush of sand, the squeal of dry wind, the mineral tang of dust storms, senses that, although human, are useful metaphors for the land's moods. Throughout these scenes, the narrator keeps returning to a broader speculative question without devolving into fantasy. How did these terrestrial architectures influence the trajectories of life? The answer is not offered as a simple cause and effect, but as a web of probabilities. Continuous mountain chains channeled species, creating corridors and barriers. Super rivers acted as dispersal highways and as cradles for unique habitats. Interior deserts compressed evolutionary space, favoring drought-adapted traits. The narrator frames these as contingent interactions, landscape shaping life, life writing itself into landscapes, and both being altered by time. There is also the question of what such a world feels like to a mind accustomed to modern maps. The narration aims to reorient the listener's sense of scale and intimacy. Modern humans tend to think in terms of borders, oceans, and travel times measured in days or hours. Pangea demanded a different metric: how many generations of trees might occupy a riverbank, how many ice advances might sculpt a pass. To inhabit that perspective is to accept the processes we deem slow are the principal narrators in an ancient world. Finally, the part closes on a reflective note about preservation and absence. Landscapes, however monumental, are fragile to the sweeping mechanisms of geology. Mountains erode, valleys fill, rivers reroute. The record of Pangea is scrawled into rock, but it is partial. Some details survive vividly: large-scale mountain stitches, broad sedimentary basins, patterns of coal and evaporite distribution. Others do not: ephemeral shorelines, transient lakes, the precise choreography of seasonal storms. The narrator invites the listener to feel a restrained wonder at what remains and a melancholy at what cannot be recovered in full. The continent was a theater of extremes: mountains that held weather captive, valleys that collected history, rivers that both connected and failed, deserts that spelled endurance, and all of it played out under an indifferent sky. The concluding image is simple and deliberate. Pangea was a landscape of contrasts: half lush rim, half parched interior, mountain belts binding continents like sewn seams, valleys wide enough to cradle entire climates, rivers that carried stories and sometimes stopped with a quiet finality. It was a world in which scale redefined possibility and where the land itself determined the terms of survival. To think of it is to confront both the generosity of Earth in creating such variety and the planet's capacity for erasure. In that tension, the listener is asked to remain curious, not because answers are neatly available, but because the questions themselves in a large perspective, inviting an appreciation of deep time's geometry and the fragile narratives it contains. What is the sound of life when it has been compressed to the edges of a supercontinent, when abundance and risk congregate where? Land meets water, and the interior offers only the austere logic of scarcity. That question arrives not as a map detail, but as a living image: foaming river mouths and creaking tidal flats, the incessant chitter of arthropods under a hot canopy, the patient rustle of conifer needles and winds made large by vastness. In the long hush of deep time, life learned to gather at margins. Along those margins, competition was not an occasional drama, but the steady grammar of existence. The voice that speaks of this world is a calm, omniscient observer, one that moves from coastline to estuary to inland river and then beneath the waves. It describes not personalities, but pressures, ecological forces that shaped bodies and behaviors, alliances and antagonisms. The narrative turns repeatedly to a paradox: diversity thrives where resources concentrate, yet those same concentrations sharpen competition until evolutionary novelty becomes the currency of survival. Along the seams of Pangea, the first great actors of the Mesozoic took shape. Early dinosaurs, small at first, then sprawling into forms that would dominate terrestrial landscapes, moved across floodplains and coastal woodlands. They were not solitary archetypes in a tale, they were ensembles in an ecological theater. The narrator expands a single scene into a long, deliberate study. Scene: the river delta at dawn. The air hangs viscous with humidity. Light breaks through a canopy of cycads and early conifers, sifting down in green shafts. The bank slopes into braided channels that smell of damp earth and decaying plant matter. Here, life congregates because the water brings food silt rich in minerals, a conveyor belt of plant detritus, fish, and invertebrates. Small archosaurs, agile, cursorial creatures, patrol the margins in search of eggs or easy prey. Herbivorous cousins nibble on seed ferns and young shoots, moving in small, watchful groups that are both social strategy and an instinctive response to predation pressure. The scene is dense with microdrama. A spring flood alters the river's course, scouring a bank and revealing a nest of eggs. The sudden loss of shelter throws a pocket of juveniles into exposure. Opportunistic feeders exploit the opening. Competition is not abstract here. It is a matter of minutes and the difference between growth and death. The narration dwells on the textures, the rebounding glint of scales under sunlight, the damp exhalations of breath, the smell of crushed leaves when a herd forces to understory. These details serve to explain a broader principle: where resources concentrate, selective pressures intensify. Skills, speed, camouflage, group vigilance are all traded for another day of survival. In the lowland swamps and marshes, another suite of life carved its own rules. Insect life, in particular, reached remarkable forms. The narrator pauses to explain factors that allowed arthropods to attain sizes beyond anything seen in modern temperate zones. Oxygen concentrations in parts of deep time were higher, respiratory systems scaled in ways that permitted greater body mass. Giant dragonfly-like predators, sweepers of the air, patrolled open glades. Millipede analogues and enormous cockroach relatives scuttled through leaf litter, their sheer biomass forming a substrate upon which other life depended. The narration treats these giant insects as ecological forces rather than curiosities, their life history shaped predator-prey relationships, dispersal of spores and seeds, and even the architecture of small vertebrates that evolved to avoid or exploit them. Competition within these insect populations took forms both obvious and subtle. As wings and jaws expanded, so did specialization. Some insects adapted to nocturnal life to avoid daytime predators. Others developed chemical defenses that made them unpalatable to hungry mouths. The narrator emphasizes that every armament, beak, claw, poison, speed, begets a counter-armament in an interminable evolutionary bargain. In the margins where life crowded most densely, that bargain became relentless. Adaptations were not just reactive, but inventive, defensive plating, social behavior, burrowing to escape surface volatility. These were not moral choices, but mechanical responses scored into genes by centuries of selection. Where land ran against sea, the drama shifted. Coasts and estuaries became crucibles. Tidal flats, muddy, smelly, and abundant, were the ultimate markets for life's trade. Crustaceans and bivalves mined the boundary layer for sustenance. In these shallow waters, microbial mats bound sediments, trapping nutrients and creating microhabitats. The narrator paints a long, cinematic vignette of the tidal rhythmicity, an ebb exposing a mosaic of pools where fish become stranded, a flow that returns with a churn of nutrients, the relentless reworking of sediments into beds that would later fossilize. Here, competition took on a different shape. It was a contest of timing and tolerance. Who could withstand variable salinity? Who could exploit tidal pulses to feed or breed? Organisms that adapted to these conditions often became ecosystem engineers, altering sediment dynamics in ways that benefited some groups and excluded others. On the shoreline, the first experiments in true coastal complexity are amplified. Estuarine forests, precursors to mangrove-like systems, anchored banks with roots that trapped sediment. These thickets were refugia for juveniles, fish, amphibious tetrapods, small reptilian forms safe from the largest predators that patrolled open waters, but refuge breeds concentrated competition. Juvenile growth rates, reproductive timing, and even migratory behaviors were tuned to the rhythm of these sheltered nurseries. The narrator takes time to unfold such an ecology into layered scenes, showing how a single estuarine pool could host both the death and renewal of generations. An algal bloom suffocates a shoal. Scavengers converge, then spores and seeds take advantage of the nutrient surge, spurring a flush of plant growth. Beyond the shore, the seas of Pantalassa and the sinuating Tethys hosted their own theaters of rivalry. The ocean is described not as an undifferentiated blue, but as a mosaic of niches, sunlit surface layers where phytoplankton blooms, lay down the basis of food webs, continental shelves brimming with calcifying creatures and nurseries for fish, and deeper basins where darkness preserved slow-moving detritivores and chemotrophic communities around hydrothermal vents. A single marine vignette is stretched and made vivid. Picture the shelf seas of Tethys, warm, shallow waters suffused with light. Reef builders, sponges, algae, and early scleractinian-like organisms constructed three-dimensional structures that trapped larvae, sheltered juveniles, and concentrated predation. Ammonites, spiraled shells floating through the water column, acted as both predators and prey. Large marine reptiles, sleek hunters adapted to a life without land-breathing lungs that limited their time below, swept through. Schoolings of fish, their sensory systems tuned to the faintest disturbances. Competition here was mediated by speed, sensory acuity, and the ability to exploit seasonal booms of life. Upwelling zones, where deep, nutrient-rich water rose to the surface, were ecological gold mines. Entire assemblages arranged their life histories around these pulses. Plankton bloomed, small fish multiplied, predators followed. Whoever tracked the pulse won a reproductive advantage. The oceanic narrative also turns to scarcity and specialization. In deep basins, where nutrients descended slowly and light could not penetrate, organisms developed strategies that would seem austere to coastal life. Bioluminescence, elongated jaws, and slow metabolisms typified these realms. Competition did not disappear, it narrowed. In a world of scarcity, every advantage counted more. Predation became a dance of stealth against a backdrop of eternal night, symbiosis between bacteria and host, between filter feeders and microorganisms emerged as stable strategies to extract energy from the least hospitable environments. The narrator emphasizes a crucial point about the fossil record as it relates to this concentration of life at margins, preservation bias. The very places where life flourished most exuberantly, coasts, deltas, floodplains, are also the places most likely to be buried, compacted, and transformed into the rock strata modern scientists study. Yet that preservation is double-edged. Rapid burial creates the conditions for exceptional fossilization, sometimes preserving soft tissues in exquisite detail, yet the same tectonic and sea level shifts that bury these ecosystems can later distort, metamorphose, or wholly erase their signatures. Thus, the abundance at margins both facilitates and complicates historical reconstruction. Competition in this telling is not merely one predator against one prey, but an ecological amplifier. When a new herbivorous clade evolves a more efficient way to process plant matter, articulated teeth, a longer gut can transform landscapes by changing vegetation structure. Those changes cascade, predators respond in morphology and behavior, scavengers alter nutrient cycles, and even sedimentation patterns shift as plant root systems rearrange soil stability. The narrator treats these cascades as stories within the larger narrative, a way to connect the anatomical to the planetary. Every innovation is a small experiment that ripples outward across ecological networks. Some innovations stabilize ecosystems, others destabilize them, triggering turnovers and radiations. Interspecies rivalry is described both as brutal and as creative. Massifs of bone and keratin testify to confrontations, horns, frills, spines, as much as to display. Sexual selection, too, plays a part. Elaborate structures may have begun as signals to mates, but then took on roles in deterrence. And rivalry, complicating the calculus of survival. The narrator resists anthropomorphism. These are not moral dramas, but evolutionary negotiations where trade-offs are continually renegotiated. Another extended vignette returns to the theme of scale, the seasonal path of life along a coastline. In spring, migratory pulses driven by temperature and productivity bring waves of organisms to shallow shelves. Spawning aggregations create ephemeral beds of larvae. Predators converge, scavengers clean up, microbes recycle. The season ends, but its imprint is left in the strata, mass mortality layers, shell beds, and isotopic shifts that capture the chemical signature of a seasonal feast. The narrator uses such scenes to underline that time in these systems is both cyclical and accumulative. Throughout these scenes, an undercurrent of tension persists. Where resources cluster, there is always the threat of collapse, overgrazing that turns a floodplain barren, algal blooms that drain oxygen and create dead zones, epidemic parasites that sweep through dense populations. Competition is balanced by cooperation in places, symbiosis between plants and fungi that enable nutrient uptake, mutualistic relationships that increase the resilience of communities. The narrator folds this duality into the texture of the story. Margins offer both opportunity and hazard, abundance and the seeds of its own undoing. Finally, the narrative returns to a reflective register. The concentration of life along coasts and rivers was not a static arrangement, but an emergent property of Pangea's geometry and climate. The boundaries of habitability, where oxygen, moisture, and nutrient cycles aligned, became theaters for evolutionary experimentation. These margins produced astonishing diversity, early dinosaurs diversifying into niches, insects expanding in form and function, marine systems inventing new modes of life in sunlit and dark waters alike. Yet the story is tempered by the knowledge that geology is merciless. Sea level changes, volcanic outbursts, and tectonic uplift could erase the very stages where that drama played out. The narrator closes with a soft insistence on humility. The fossilized bones and compressed leaf impressions that survive are not complete narratives, but fragments, vivid chapters immune to time in some respects, and silent in others. To stand with this knowledge is to feel small before the mechanics of deep time, and simultaneously to feel a deep kinship with a planet that has been both creator and destroyer. Margins, edges, coasts, these were the places life chose and was shaped by in their crowded and competitive spaces. Evolutionary futures were forged, and the echoes of those choices still resonate in the anatomy of modern life and in the stones. That science reads as its script. What is the weight of an ocean when memory itself is measured in stone? That question hovers, an image rather than a map, before the listener is drawn into the less told story of Panthalassa, the great forgotten ocean that wrapped the supercontinent like a thought. To stand mentally upon its vanished surface is to feel both a vertigo of scale and a peculiar intimacy. An ocean so large that its circulatory logic differed from anything seen today. An ocean whose geological heartbeat was as decisive for life as the sea's surface light. The narrator begins here not with coordinates but with consequence. The ways in which the planet's internal movements and the chemistry of seawater conspire to make Panthalassa a world. Apart, biologically, chemically, and narratively, Panthalassa was not a passive expanse. Its name evokes continuity and concealment at once. From the surface, currents ran long and unbroken, forming gyres that could extend around a hemisphere. Beneath, the sea floor told a different story. Ridges and trenches, plumes and chimneys, the slow convulsions of mid-ocean spreading and subduction that choreographed the supply of life's basic ingredients. The sixth element in the larger story, geologic activity and nutrient dynamics, becomes a chapter about plumbing. How the Earth's inner heat, the grinding of plates, and the weathering of distant mountains delivered the salts, metals, and organic substrates that allowed oceans to be more than water. The narrative shifts into these deep mechanisms with a sense of quiet urgency, because they are the underwritten rules of ecological possibility. Imagine the mid-ocean ridge as an enormous seam where the planet repaired itself and, accidentally, fed life. There, basaltic lava extruded and cooled, building new crust and generating hydrothermal systems. Hot, chemically charged fluids, black smokers in their more dramatic instantiations, spewed mineral-rich plumes into cold seawater. Those plumes were eddies of creation, iron, sulfur, manganese, and a menagerie of trace metals dissolved in superheated water and then precipitated as chimneys, as mineral gardens. In the darkness, beyond the reach of sunlight, chemosynthetic microbes found an energy source. They chewed inorganic chemicals and exhaled organic matter, seeding localized ecosystems that supported vast communities of tube worms, bivalves, and crustaceans. The narrator treats these vent fields as both literal and metaphorical lifeboats, places where life's inventiveness was less beholden to the sun and more to the planet's interior. That interior supply mattered even far from the vents. Upwelling zones, regions where deep, nutrient-rich water rose to the surface, created seasonal or persistent productivity belts. In Panthalassa, with fewer constricted basins and a continuous rim of land, the geometry of upwelling may have favored enormous, persistent blooms where nutrients were abundant, plankton proliferated, and with plankton came the food webs that sustained larger life, filter feeders, nectonic predators, and in time, the colossal migrators of Mesozoic seas. But the narrative refuses to treat abundance as simple fortune. The same surges in productivity could destabilize oxygen levels when the organic matter sank and decayed, consuming dissolved oxygen in the depths and fostering anoxic conditions that were lethal to many forms of life but hospitable to others. Adapted to low oxygen chemistry, the interplay between tectonics and nutrient flux is an orchestra of slow percussion. When continents erode, rivers deliver weathered minerals, phosphorus, silica, iron into coastal shelves. Volcanic eruptions, whether sudden and explosive or effusive and long-lived, lofted ash and soluble iron into the atmosphere and onto seas, occasionally fertilizing surface waters. Within Panthalassa scale, a single volcanic province or cluster of submarine eruptions could, in principle, alter regional productivity for millennia. The narrator expands this into a long contemplative vignette, the ash plume that travels thousands of kilometers. Settling across the ocean and triggering a distant phytoplankton bloom, the bloom collapses under its own weight. The decay depletes oxygen at depth, and a black shale begins its slow accumulation on the seafloor, an archive of upheaval and consequence. There were other subtler chemical nudges. Serpentinization of oceanic crust when peridotite reacts with seawater at slow hydrothermal temperatures produces hydrogen. Hydrogen, in turn, can be a substrate for microbes that build organic matter without the sun. Methane seeps, slumping sediments, and the slow liberation of trace metals at the sediment-water interface added further complexity to nutrient mosaics in niches where these processes were abundant. Life stitched itself into patterns not governed by latitude but by chemistry and substrate. Yet not all of Panthalassa's seascapes were gardens. The ocean's vastness permitted regions of sluggish circulation, basins that could trap water and isolate it from the ventilating currents. In such zones, oxygen sagged. The fossil record and the chemistry preserved within it speaks of intermittent anoxic events where vast tracts of ocean turned low in oxygen killing organisms that relied on respiration but allowing anaerobic microbes and self-recycling communities to thrive. These events are not mere footnotes. They reshaped evolutionary trajectories, pruned clades, and opened niches for opportunists. The narrator does not explain them as malevolent, but as planetary processes, thresholds crossed when climate, tectonics, and oceanic configuration aligned. A panoramic scene helps to make this palpable. Picture a great basin, walled by distant submarine ridges and open to a wide expanse of surface. For a long season, winds drive surface waters offshore, deep water wells up along a margin, sustaining blooms. Carbon sequestration proceeds as organic material sinks. Then an orbital shift or a volcanic pulse alters circulation subtly. The deep water no longer replenishes oxygen quickly enough. Over centuries, the basin becomes a slow oxygen sink. In the sediment at the bottom, reducing conditions precipitate pyrite and preserve organic carbon in high concentrations. Millennia later, when uplift and erosion expose those layers, they are read as a black band in the rock record, an echo of a basin that once breathed poorly and darkly. The narrative dwells on these anoxic episodes with a careful tone, neither alarmist nor clinical. They are demonstrations of how geology and oceanography together create constraints on habitability. The same processes that create fertile upwelling can, under different conditions, produce dead zones. The ocean is a system of trade-offs and thresholds. Pantalassa's physical geometry also constrained its thermal structure. With a near contiguous expanse of open water, temperature gradients and current paths were different from today's patchwork of basins. The lack of large interrupted basins could favor stronger pole to equator heat transport in some scenarios, but it could also intensify stratification in others, particularly where surface warming created a persistent warm layer over cooler depths. Stratification inhibits mixing, and inhibited mixing can isolate deep waters from oxygen and from the trace elements delivered by surface and shelf processes. In such a stratified realm, nutrients can be trapped where they are unproductive, and the ocean's capacity to support life can hinge on episodic pulses of mixing storms, tides, or tectonic upwellings. Submarine landslides and turbidity currents further complicate the portrait. Along the continental margins and in submarine canyons, sediment-laden currents rush downslope, carving channels and depositing immense fans on the abyssal plain. These mass movements were both destructive and preservational. They stripped shallow shelves of sediments, sometimes burying living communities in sudden catastrophe, and they delivered organic matter to the deep, fostering the conditions for exceptional preservation in some depositional basins. The narrator elongates this into a scene of violence and preservation. A storm destabilizes a saturated slope. A turbine of sediment cascades into darkness, burying reefs and estuarine forests. And the sediments, entombed, will become a future archive, a moment of life frozen by catastrophic burial. There is a melancholic logic to the ocean's capacity for erasure. Oceanic crust is largely ephemeral on geologic time. It is born at ridges and consumed at trenches, cycling on scales of tens to hundreds of millions of years. The oldest oceanic crust today is far younger than the planet itself, precisely because the seafloor is consumed again and again. For Pantalassa, that implies a profound limitation on the permanence of records formed on mid-ocean plates. The rock beneath the deep water, unless it was later accreted to continents or sealed within an unusually stable margin, was likely to be recycled into the mantle, taking with it the direct physical traces of seafloor communities. What survives then is often the margin, sediments preserved on continental shelves, tectonic sutures where oceanic fragments were thrust onto land, and chemical signatures captured within continental rocks. The narrative emphasizes the bias this creates. The most exuberant ecosystems of Pantalassa may have been ephemeral in geological terms if they sat on plates destined for subduction. Exceptional fossil sites, those rare slivers where delicate anatomy is preserved, are often the product of rapid burial in conditions that later escape metamorphism. Yet such sites are sparse relative to the ocean's enormity. Thus, the picture of Pantalassa's life is both richly textured and frustratingly incomplete. The narrator uses this to broach a philosophical point. The planet preserves some stories with cinematic clarity and others only as smudged impressions. That incompleteness gives rise to questions that are scientific in form and speculative in tenor. What chemical fingerprints might survive where physical forms do not? Isotopic ratios in carbonate beds can speak to past productivity and temperature. Trace metal anomalies can indicate volcanic fertilization. Biomarkers, molecular fossils can whisper the presence of specific microbial lineages long gone. The narrator invites the listener to imagine reading these chemical runes as one would read a palimpsest, layers of meaning, each partial and ambiguous but cumulatively suggestive. These are the clues modern science uses to reconstruct Pantalas's invisible currents. The story also touches on extinction and recovery without moral drama, only process. When volcanic provinces erupted, when orbital forcing shifted climate, when circulation patterns altered, whole assemblages faltered. But the ocean's restlessness also fertilized novelty. Chemosynthetic communities persisted under and beyond mass mortalities. Opportunistic lineages radiated into vacant niches. Reef builders reassembled on whatever substrate remained. The narration insists on the non-teleological nature of these shifts. Extinction is pruning, radiation is response. Neither is malice. Both are mechanics of an animate planet. A scene of long-term consequences expanded, the quiet, inexorable enrichment of an abyssal plain with organic carbon over millions of years. Burial of that carbon sequesters atmospheric CO2 on geologic timescales, gradually altering climate and, in turn, ocean chemistry. Conversely, massive releases of carbon, whether from volcanic emissions, methane hydrate destabilization, or the oxidation of buried organic matter, can flip the system toward warmth and ocean stratification. The narrator threads this into the larger meditation. The ocean is not merely habitat, it is a regulator of planetary state, tied into carbon cycles that determine climate and the very chemistry of life. Toward the end of this section, the voice turns reflective. Pantalas's geologic vivacity, its ridges, vents, eruptions, and sediment flows, made it a crucible for life's experiments and a sometimes unforgiving judge. The planet's inner fire fed the seas. The weathering of far-off mountains sustained plankton. The angles of ridges and trenches set the rhythms of mixing and stagnation. In every instance, the physical and chemical shaped the biological. The narrator insists on humility here. When modern observers interpret a layer as evidence of bloom or burial, they are conversing with a system that is both foreign and familiar. The same principles apply: nutrient supply, oxygen balance, energy sources, but their configuration under Pantalas's scale generated outcomes that could look startling from a present-day vantage. Finally, the section closes with a quietly insistent question rather than an answer. What traces of that ocean's particular moods remain, not only in rocks and isotopes, but in the living lineages that trace their ancestry through that deep time? Some modern groups carry molecular stories, biochemical residues, or anatomical adaptations that began in oceans very different from ours. Others are distant echoes with no clear contemporary analog. Pantalasa, the forgotten ocean, is both a scientific frontier and a philosophical device, an invitation to consider how geology and chemistry conspire to make possible the diversity that once rode its currents, and how much of that diversity is now hidden below plates and in chemical signatures waiting to be read. The narrator leaves the listener with a sense of careful wonder. The ocean that once encircled the world was not simply water in motion. It was a dynamic ledger of geologic activity, a network of nutrient pathways, and a theater for evolution's boldest improvisations. To listen to its story is to learn patience, to read sediments as time, to interpret chemistry as narrative, and to accept that some secrets may remain submerged until curiosity and method discover new ways to lift them toward the light. Pantalasa may be forgotten in common maps, but in the rocks and the chemical whispers of the planet, it keeps speaking, if only one knows how to listen. What image first arrives when one imagines a continent that refuses to be whole? It is not a single crack, but the insistence of many small betrayals, hairline fractures at first, and seams that widen like the mouth of a patient animal. That image of a supercontinent beginning to tear serves as the hinge for this chapter. It asks the listener to hold together two sensations at once: the absurd slowness of the break and the suddenness with which its consequences rewrite the world. The rifts that would carve Pangea apart began as whispers beneath the crust. The lithosphere, a brittle veneer that raised the convecting mantle, thinned in places as heat upwelled. Mantle plumes, columns of relatively hot rock rising from the deep pressed upward against the underside of continental plates. The result was a slow heating, a gentle inflation. Rocks that had been cool and stiff softened, the crust stretched. At first the surface showed only subtle signs, a field of small, normal faults, narrow gravens, basaltic fissures. Yet these modest beginnings were the geological seed of continents to come. Over millions of years, what began as tens of kilometers of stretching could become thousands. The continent, once a single sheet, acquired a pattern of cracks that presaged a new geography, one in which Gondwana and Laurasia would eventually assert themselves as independent actors. To translate mechanism into drama, imagine a long valley forming where none had been. The crust does not split neatly like a plate. It thins unevenly, fracturing into a network of faults and grabens. Rivers find these weaknesses and begin to use them as drainage lines, cutting into softening rock. Lakes collect in subsiding basins. Erosion follows. Lakes deposit sediments. Sediments load the crust and pull it down further. The rift grows, not merely by tectonic force, but by the collaborative work of water and gravity. What looks at first like a narrow wound becomes a broad, sagging seam, a rift valley whose sides may host active volcanism. Where dikes map the path of melted mantle and volcanic provinces paint the land in dark basalt. In some locales, the mantle made its voice heard more emphatically. Large igneous provinces poured basalt in monumental sheets, flood basalts that covered vast tracts of land. These events had immediate and far-reaching consequences. Rivers choked on ash and lava flows. The atmosphere dimmed for years at a time, and the chemistry of oceans could be nudged by soluble elements delivered in ash. The geological record retains these volcanic breaths as thick, dark beds. They are milestones in the slow unweaving of a continent, the moments when the planet's interior intervened decisively in the work of splitting land. Rifting followed no single script. In some regions it stalled. The crust found ways to accommodate deformation without opening fully into ocean. Elsewhere, rifts organized into more coherent systems, linked by transformed faults and separated by accommodation zones. As rifts lengthened and the lithosphere thinned, seawater at times invaded, turning inland basins into nascent seas. These ephemeral embayments are the first whispers of new oceans, strips of marine water that would one day widen into seas, and seas into full-fledged ocean basins. One of the story's essential pivots is the birth of embryonic oceans. These begin as narrow seaways, sometimes only a chain of interconnected lakes that, through subsidence and marine transgression, become saline corridors. The narrative lingers on a scene, a low coastal plain, fractured and subsiding. Tides creep inland with each high sea level. Salt accumulates in the lowest depressions. Marine organisms colonize new shallow shells. Limestones begin to form where reefs take hold. The act of turning continental sediment into marine carbonate is a quiet revolution. It is both a physical reconfiguration, land turned to shelf, and a biochemical one. Shallow marine conditions foster different life, different sedimentation, different carbon cycles. Over epochs, such corridors expand. Plate motions, once they pass a threshold, create a persistent oceanic gap. Oceanic crust begins to form at a mid-ocean ridge, and seafloor spreading makes separation literal. The opening of the Atlantic in its embryonic stages is an instructive exemplar. What began as a rift system, an array of basins and faults between what would become modern-day Africa and South America, gradually widened. Magma upwelled to fill the thinning space, cooling as basaltic oceanic crust. The sides of the rift subsided to form passive margins, expansive shelves behind steep continental escarpments. These margins would become archives, thick wedges of sediment, organic-rich shales, and deltaic complexes that recorded the slow drift of continents away from one another. In the rock record, such margins tell the story of a coastline splayed open, sandy shorelines reworked into barrier systems, estuaries buried by successions of river deltas, seas that gradually deepen as the rift floor sinks and sea level encroaches. As new oceans appeared, the planet's circulatory logic altered. Before the breakup, Panthalassa had been the dominant oceanic body, its currents long and uninterrupted. With the birth of interior basins and new ocean basins, currents began to fragment and reorganize. A narrow opening could reroute a current thousands of kilometers downstream, altering upwelling zones and nutrient fluxes. The opening of the Proto-Atlantic did not simply place water between two landmasses, it rewired climate. Once a seaway opened, it could allow heat and salinity differences to equalize in new ways, changing weather patterns along distant shores. Over millions of years, those shifts in ocean circulation rearranged precipitation belts, nudging monsoons and altering the reach of moisture deep into continental interiors. Where there had been vast aridity in the heart of Pangea, moisture began to creep in along newly formed corridors. Some deserts retreated, while others simply shifted. The continental fragments that would be named Gondwana and Laurasia followed separate but intertwined trajectories. Gondwana, composed of what would later fragment into Africa, South America, Antarctica, India, and Australia carried within it a nested architecture of rifts and sutures. Laurasia, the northern counterpart, stiffened and broke along a different set of fault lines. Their separation was more than nomenclature. It was the genesis of distinct biogeographic theaters. Plants and animals once able to traverse a unified continent found themselves stranded on drifting parcels of land. Over time, these isolations compounded into unique evolutionary pathways. The narrative hovers over this transition without lapsing into sentimentalism. Species distributions are reframed as contingent responses to geography's rearrangement rather than as moral tales of loss. A vignette expands this idea into a tactile sequence. A coastal plain that once provided a continuous habitat for a lineage becomes an island of refuge as water floods the gaps. Populations divided by shallow seas diverge. One clade evolves tolerance to cooler currents, another adapts to a warmer saline-influenced shelf. The geological processes, the rifting, transgression, and formation of new coasts provide the stage, but the actors are the selective pressures that attend them. Over the long arch of evolution, these pressures accumulate into differences so pronounced that paleontologists can read them as divergent lineages in the fossil record. That evidence, the matching of fossils across now distant coasts, became one of the cornerstones for the recognition that continents had indeed been connected. Yet not all separations were neat. Transformed faults offset rift systems, creating patterns of alternating uplift and subsidence that complicated coastline evolution. Some rifts aborted, their motion transferred elsewhere. Some widened into full oceanic basins. The Arctic and Indian Oceans emerged through their own particularities, India's northward drift being a dramatic late arrival as a microcontinent that rammed into Asia, uplifting the Himalayas and closing portions of the ancient Tethys. The closure of seaways was just as consequential as their opening. Land bridges formed and dissolved, permitting episodic migrations and then isolating faunas in new ways. The tectonic choreography of opening and closing seaways produced a planetary atlas of possibility corridors and barriers that would determine the dispersion of life. Seafloor spreading left its own signature, magnetic stripes on oceanic crust, mirror image bands of alternating polarity that testify to epochs of geomagnetic reversals. These anomalies are the patient handwriting of spreading centers. They allowed later scientists to measure the tempo of separation, to watch continents pull apart in a strip chart memory written in basalt. But the process is not merely technical, it is aesthetic. The idea that the seafloor preserves a rhythmic record, a barcode of time, aligned with the narrative's core meditation. Earth keeps time in layers and patterns, in banding and in weathered cliffs. As oceans widened, margins cooled and subsided. Passive margins, once gentle shelves, accumulated sediment until they became sites of marine richness, carbonate platforms, reef systems, and vast hydrocarbon sequestering deltas. These environments, often prolific in preserving organic matter, would much later be exploited by human industry, but in the deep time story their role is to transform the chemistry of oceans and atmosphere. Burial of organic carbon on continental margins is a slow carbon sink, one that stabilizes atmospheric CO2 over geological spans. Conversely, uplift and erosion of those sediments can liberate carbon, nudging climate toward warmth. Thus, the breakup of a supercontinent is not merely a rearrangement of maps, it becomes a major lever in Earth's long-term carbon cycle. The process of fragmentation also magnified the planet's propensity for novelty. New, shallow seas fostered reef complexes and carbonate factories. Their ecological architectures provided new niches. Ocean gateways, narrow passages linking basins, acted as ecological filters, transforming the composition of migrating faunas and floras. Where once a taxon could roam unimpeded along a continuous shoreline, it now met currents, salinity gradients, and competitors at straits that required specialization to cross. In this way, the physical act of splitting opened new evolutionary opportunities even as it closed others. The breakup carried with it profound climatic aftershocks. The opening of southern ocean gateways around Antarctica, which would become fully realized much later, reconfigured polar currents. The development of a circumpolar current isolated Antarctica thermally, encouraging glaciation that would tilt global climate into cooler regimes. The creation of the modern Atlantic and Indian basins changed heat transport, and with it the positioning of climate belts. The narrative emphasizes causality without oversimplification. Tectonics set the geometric possibilities, atmospheric physics, oceanography, and orbital mechanics modulated the outcome. Together, they drove wholesale changes in rainfall, temperature gradients, and seasonality changes that in turn reshaped biomes. Through all this, the record is fragmentary and selective. The most direct traces of continental tearing rift basins, flood basalts, and passive margin sediments are preserved in some places and erased in others. Subduction consumes oceanic crust, erosion scours young mountains, sediments are recycled into new rocks. Yet enough survive to let modern science reconstruct the sequence. Paleomagnetic data that points to former latitudes, matching rock sequences and fossil assemblages across now separated coasts, isotopic signatures that track ocean chemistry through time. These are not clean narratives, but palimpsests, overwritten, partial, and demanding interpretation. The narration lingers on the melancholy and the wonder that attends such erasure. The moment a seaway opens, it becomes both a creator and a destroyer. It creates new habitats while drowning others. It sequesters sediments and erases landscapes. The listener is invited to feel the paradox. Geological processes work in scales that make human history seem instantaneous, yet their products endure in ways that can be read by patient inquiry. The breakup of Pangea did not merely redraw coastlines, it rewrote the ledger of life's possibilities. Finally, the voice widens into a reflection on contingency. Tectonic forces set certain tracks. Rifts will form where the lithosphere thins. Oceanic crust will be born at spreading centers, but the exact choreography is fraught with chance. A plume's timing, a volcanic pulse, the direction of plate motion, all can tilt outcomes. A rift that initiates in one place may relocate tens of kilometers away. A corridor that connects seas may persist for millions of years or close within a geological blink. Such contingencies are the source of Earth's creative richness. They are the reason similar starting conditions can lead, through the slow, repetitive agency of plate tectonics, to wildly different ends. As the chapter closes, the listener is left with a layered image, a continent that once seemed inevitable, now fragmenting into pieces that will sail slowly and define the oceans we recognize today. The scene is at once violent in its implication and serene in its slowness. Rift valleys become seas, magma sculpts new crust, passive margins gather sediment and life, ocean currents rewrite climate. The breakup of Pangea is not a single event, but a cascade of interlocking processes, tectonics, volcanism, sedimentation, oceanography. That, together, opened the modern oceans. In that opening, the planet found both division and abundance, scars and new margins, and in the rock record, an invitation to read not only what was preserved, but also what has been lost to time. What does it mean to carry the memory of another planet beneath the feet of the living? That question sits at the threshold of this chapter. It asks the listener to consider the modern map not as a final product, but as a palimpsest, a surface onto which the long dramas of rifting, drifting, and suturing have been written, erased, and rewritten. The legacy of Pangea is everywhere, often in plain sight. Coastlines that still fit against one another like the edges of a broken vase, mountain ranges whose scars match across oceans. Fossil clues that speak of creatures once able to walk from one shore to another without ever knowing the sea that now divides them. Those echoes are not mere curiosities. They are the archive of a world that began to peel itself apart roughly 135 million years ago, and they continue to shape climate, ecology, and even human economies today. The most immediate and cinematic evidence is the fit, the visual uncanny of two continents matching. That image has its own small mythic power. South America's bulging east flank tucks into the curve of Africa's west. When the continents are seen not as bureaucratic territories but as fragments of a single sheet, the idea arrests the imagination. Yet the superficial fit of coastlines is deceptive if taken at face value. Shorelines bend and change with tides, sea levels, and the accretion of sediment. The more honest fit is deeper, the contours of continental shelves. When geologists lay the shelves against one another, the puzzle becomes precise. Passive margins, those broad, gently sloping shelves and slopes that front today's Atlantic, reveal matching scars and complementary geometries. They are the submerged memory of where land once clasped land. They provide the true seams of separation preserved beneath the sea's surface. But a matching coastline is not proof alone. The planet offers a chorus of independent testimonies that converge on the same story. There are mountain ranges whose bones continue across what are now watery divides. The Appalachian chain in North America, when traced eastward, does not simply peter out. It continues into a lineage of uplifted rocks in Greenland and northern Europe, the Caledonian and related belts, together recording the same ancient collision and subsequent erosion. The rock types, the ages of metamorphism, and the structural fabrics align in a way that is unlikely to be coincidence. These stitched belts are tectonic fingerprints, long-worn signatures of the collisions that welded continents together and the fractures that later unraveled them. Fossils offer another, more intimate kind of concordance. In the rocks of Brazil and in the beds of Namibia, paleontologists find the same freshwater reptile, an animal that by all modern logic could not have crossed an ocean. In southern continents, Africa, South America, India, Antarctica, and Australia, plant fossils such as Glossopteris appear in contiguous stratigraphic contexts. Their leaves and seeds preserved in swamps and coals that once spanned what became many continents. Even the stony records of ancient ice glacial tills and striations speak in a common voice when found in now disparate southern lands. The alignment of glacial direction suggests a united, colder southern expanse at certain moments in deep time. These shared remains are not metaphors, they are rigorous data. They are the traces by which scientists reconstruct the choreography of breakup and separation. Yet the transition from a unified landmass to the modern archipelago of continents altered more than geography. When rifting opened nascent ocean basins, the creation of new passive margins rewired coastlines and basins into new climatic and ecological regimes. The formation of the Proto-Atlantic was a slow, deliberate surgery. Rift basins sank, magma rose to make new crust, and once a spreading center established itself, the gap widened without ever requiring dramatic human-like intention. Over tens of millions of years, the geography rearranged the flow of air and water. Ocean currents found new pathways, and with them the transport of heat, salt, and nutrients changed. These changes in ocean circulation nudged monsoon belts, reconfigured storm tracks, and remade the precipitation patterns that determined which regions would become deserts and which would remain green. There is a kind of poetic justice in the fact that the geological signatures left by breakup still have material consequences for life and for human societies. The same passive margins that reveal how continents once fit also host some of the richest sedimentary basins on Earth, thick wedges of deltaic sands, organic rich shales, and carbonate platforms. Those basins are now the repositories of hydrocarbons, the buried remains of former biological abundance that modern civilizations dig and burn. Coal seams, too, the compressed remains of swamp forests that flourished on the edges of Pangea, became the engines of industrial transformations millions of years later. River systems that once fed inland basins and deltas distributed weathered minerals across continents, the soils derived from. Those sediments underwrite modern agriculture. In this way, the slow mechanics of rifting and margin formation reached forward to touch economies, politics, and daily life in ways invisible on the surface map. Scientific techniques transformed the fit from impression to proof. Paleomagnetism, for instance, recorded the orientation of iron-bearing minerals as they formed, providing a compass frozen in rock. Rocks of a certain age in what are now separated continents show identical magnetic latitude signatures, indicating that, when they formed, those rocks faced the same poles. In the youngest oceanic crust, magnetic stripes arc away from mid-ocean ridges like barcodes, an unmistakable record of seafloor spreading. Radiometric dating constrains the tempo. Together, these methods turn the idea of continental drift from a poetic conjecture into an empirical tapestry. Convergent lines of evidence from magnetism, matching stratigraphy, fossil distribution, and structural geology all point to a world once whole and later divided. There is an emotional contour to this reconstruction that the narrator tries not to sentimentalize but to respect. When the pieces are laid side by side, a sense of continuity emerges that is almost mournful, an awareness of how many patterns have been interrupted. The animals that once traversed continuous plains found their ranges split, lineages that once intermingled took separate evolutionary paths. In biogeography, this breakage is called vicariance, the fragmentation of ancestral ranges by the rise of barriers. Over tens of millions of years, vicariance seeded divergence. It is why marsupials thrived in Australia and South America but largely not elsewhere, why certain plant families have distinct Gondwanan distributions, why the fauna of Madagascar diverged so markedly from continental Africa. The rifting was not merely a reconfiguration of stone, it was a distributive act, parceling ecology and opportunity into distinct theaters for evolution. Modern coastlines continue to be shaped by the legacy of that separation in less obvious ways. Continental shelves, the submerged edges that once abutted neighboring lands, harbor stratigraphic records of sea level oscillations, sediment supply, and ecological shifts. In seismic profiles, these shelves reveal nested sequences of deltas and terraces, testimonies of rivers that once found different oceanic exits before continents drifted apart. Coastal morphology reflects the memory of ancient margins, broad shelves where the rifted edge subsided slowly, narrow shelves and steep escarpments where rapid uplift left a thinner edge. Those differences influence present-day marine productivity, fisheries, and coastal risk. In short, the way humanity experiences coastlines, where ports are safe, where sediments collect, where storm surge concentrates, is a consequence of tectonic chapters that began in the Jurassic and before. But the record is not perfect. Erosion, sedimentation, metamorphism, and subduction erase as much as they preserve. Oceanic crust is ephemeral on a planetary scale. It is born at ridges and consumed at trenches. Whole swaths of mid-ocean lithosphere that once bore life are now recycled into the mantle, their direct physical remains lost. Thus, much of the ocean's original fabric, its ancient seafloor ecosystems, are forever inaccessible. What remains are the margins, the arcs of passive shelf, the fragments of ocean crust that were thrust onto continents as ophiolites, and the chemical signatures left in sediments and sediments' isotopic ratios. It is in these fragments, matching mountain roots, fossil echoes, magnetic barcodes, that the story is pieced together. The incompleteness introduces an ethical humility into the science. The planet yields its history in parts, never in whole. That humility extends into speculative territories as well. Where evidence is thin, imagination is tempted to fill gaps with narrative. The narrator resists contrived inventions but does not refuse the human impulse to speculate. The question becomes disciplined. What kinds of things could survive the grinding ruin of tens of millions of years and the migrations of plates, terraces cut into bedrock, mineralized surfaces, and boulder alignments can survive for surprisingly long spans if they are buried and later exhumed. Chemical signatures, biomarkers, unusual concentrations of certain isotopes can persist and provide whispers of past ecosystems that physical forms cannot. If anything, the fragmentary nature of preservation should encourage interpretive creativity anchored to evidence, not romantic certainty. That is the speculative posture of a mature humility, to ask boldly, but to require proof. The consequences of Pangea's breakup are also written in living lineages. Biogeographic patterns are a kind of genetic palimpsest, sister groups in distant lands in the flora of southern continents. And clades of freshwater fish and certain reptile groups bear molecular traces of ancient dispersal and long isolation. Molecular clocks, which estimate divergence times based on mutation rates, often align with geological timelines of rifting and seaway formation. Those concordances do more than corroborate plate tectonics. They show how life's branching pattern is, in part, authored by the geometry of land and sea. Even where dispersal after breakup occurred by island hopping, rafting, or later, land bridges, the initial vicariants set starting conditions that shaped evolutionary possibilities across epochs. There is also an aesthetic legacy. The maps and models that reconstruct Pangea and its breakup have a contemplative appeal. Paleogeographic reconstructions, whether rendered as colored maps or animated sequences, make visible the choreography of continents. They show how shallow seas danced into existence and receded, how mountain belts rose and bled sediments into the newest ocean basins, how passive margins accumulated riches of biology and later hydrocarbons. For those who look at them, the maps are not merely tools, but invitations to scale thought, an invitation to move beyond human timescales into epochs measured in tens and hundreds of millions of years. They are reminders that the world's present arrangement is a single frame in an ever-moving film. The final, and perhaps most intimate, legacy is in perspective. The knowledge that continents were once joined reframes modern anxieties. Borders drawn on maps become less absolute. Oceans that today separate nations were once traversable land. The modern distribution of climate zones, the pathways of monsoons, the locations of deserts and fertile plains, these are all contingent on where continents sat and how oceans flowed. Human history unfolds on a stage whose architecture was largely set long before humans walked. To appreciate that is not to diminish human significance, but to widen it, to see human enterprise as a brief, brilliant modulation upon a planet whose scenes are older than any polity. In the quiet that follows such an accounting, one can hear an echoing insistence. To read the world is to accept both what is preserved and what has been lost. The matching coastlines, the complementary shelves, the geological and fossil concordances, these constitute a language by which Earth tells a portion of its story. They teach a method as much as a fact. Look for patterns that converge across independent lines of evidence. Prefer the deeper geometries of shells and basement rocks over fleeting shorelines. Accept uncertainty as an invitation to better tools and more careful questions. The legacy of Pangea is thus doubled. It is a set of physical traces that continue to shape climate, life, and human industry. And it is a lesson in humility that the planet preserves its past in fragments, and that to assemble those fragments into a coherent history requires patience, curiosity, and a willingness to live with the vastness of time. So when the modern map is folded in the mind and the Atlantic's wide blue ribbon is stared across, there is more than a visual gap to reckon with. There is a story of slow fracture and new currents, of life divided and reinvented, of margins where abundance concentrated, and of interiors that learned austerity. Coastal shells fit not simply because of happenstance, but because of a shared origin. Mountains continue in their bones because the seams were once sutured. Fossils bridge oceans because those oceans did not yet exist for the creatures that left their marks. The legacy of Pangea persists, not as a single monument, but as a distributed archive in rock, sea, and living lineages, a reminder that the world's present is a composite of ancient unions and long separations. To read that archive is to feel both small and connected, perched on a fragment of crust that remembers being whole. What does it mean, the narrator asks, when continents that today wear different faces, South America, Africa, India, bear the same fingerprints of life? It is not merely a curious coincidence, but a question that invites the listener to reorient the sense of place. Across oceans and millennia, the same fern leaf appears in stone, the same freshwater reptile swims in two riverbeds that are now separated by an expanse of salt. These echoes are more than fossils. They are sentences in a slow letter written by the planet, addressed to anyone patient enough to read in rock. The most direct testimonies are blunt and beautiful. In Permian and Triassic deposits scattered across what would later become South America, Africa, India, Antarctica, and Australia, paleobotanists have found the same distinctive plant assemblage, braided leaves and seed-bearing mats that, in life, formed sprawling swamp forests. Glossopteris, a genus of seed fern, appears in coal seams across these southern lands. Its presence is not incidental. In a world of limited dispersal options for heavy seeds and sturdy spores, such a continuous distribution implies contiguous ground. Along river channels preserved in sandstone, paleontologists have recovered fossils of Mesosaurus, a small freshwater reptile. How did such a creature traverse an ocean? The simplest answer, shared land, remains the most persuasive. The geology concurs. Rock sequences that line up in age and character across near opposite coasts are a puzzle piece set into place by time. Coal beds layered between sandstones and shales in Brazil find their counterparts in the Karoo of South Africa. Glacial tillites, striated pavements, and drop stones in India echo glacial signatures in South America and Africa, pointing to a cold episode that engulfed the united southern landmass. Structural geology reads like forensic evidence. Belts of metamorphosed rock, once part of the same mountain range, now lie separated by thousands of kilometers of ocean. Orogenic episodes, the Pan-African and Brasiliano orogenies among them, stitch together continental fragments, and their scars can still be traced from one modern shore to another if one knows where to look. There is, in these correspondences, an emotional register that the narrator cannot avoid. The disciplined delight of a scientist recognizing a pattern is akin to the quiet astonishment of seeing an old friend in a crowded place. That recognition carries humility. Continents that seemed fixed on maps were once mobile actors in a planetary play, and life responded to the stage they offered. The distributed biota of Gondwana, South America, Africa, India, Antarctica, Australia tells not simply of migration, but of deep ecological continuity. The same climatic envelopes, the same mountain-rimmed basins, the same wet margins gave life similar shapes and opportunities. In that continuity there is a sense of both kinship and irretrievability. The planet retains memory, but only in fragments. Fragments, however, are not silent. Rocks conserve chemistry, textures, and sometimes impressions of behavior. Sedimentary beds preserve ripples of an ancient shore. Stromatolites record microbial matwork in shallow seas. Coal seams whisper of dense swamp canopies. Mountain belts, even when eroded to stumps, carry metamorphic histories that tell when and how rocks were piled into mountains. These are the means by which scientists read the past. They are also the same mechanisms that complicate any hypothesis that proposes a different kind of past, one in which intelligence, left marks that time has obscured. The speculative question presses at the edge of this archive. Could something other than the known lineages of life have arisen in deep time, an intelligence capable of altering landscapes, shaping matter, leaving deliberate traces? It is a question of enormous imaginative appeal and, at the same time, one that can be framed scientifically. The narrator insists upon a disciplined curiosity. Speculation is permitted, but it must be tethered to what the rocks do and do not allow. To approach the hypothesis, one must first acknowledge temporal and environmental constraints. Evolutionary complexity, the kind that leads to large brains, social organization, and the manipulation of the environment, does not arise in a day or for a single cause. It is a long, contingent process, dependent on stable ecosystems, available resources, and selective pressures that favor cognition and social coordination. The histories of Earth's major transitions, multicellularity, complex animals, terrestrial colonization, mammalian diversification, each took tens to hundreds of millions of years. There is nothing intrinsic in that biochemical narrative that forbids intelligence in other forms or at other times, but the probabilistic hurdles are tall. Perhaps more decisive are the physical processes that govern preservation. The planet is both archivist and eraser. Continental crust, where a hypothetical industrial or architectural signature would most plausibly appear, endures longer than seafloor, but even it is subject to metamorphism, burial, and erosion. Mountain belts that once rose high have been planed down and then reborn. Basins that once collected artifacts have been subducted or uplifted and scrubbed by rivers. Oceanic plates, conversely, are transient born at ridges, consumed at trenches, so anything placed on oceanic crust is unlikely to survive the long sweep of plate tectonics. The oldest oceanic lithosphere rarely exceeds 200 million years. Most of it disappears sooner. Continental interiors, cratons, and shields are stable over eons, yet they are also frequently chemically altered by heat, pressure, and fluid flow, which can obscure or destroy delicate traces. If a vanished intelligence did exist, what would modern investigators plausibly be able to find? The narrator outlines a taxonomy of potential remnants, each weighed by survivability. First are geomorphic modifications on truly large scales, terraces, canals, and earthworks. Large linear embankments or altered drainage patterns can persist if they are cut into resistant bedrock and then buried under sediment in an anoxic basin. Later exhumation might reveal them as unnatural terraces or abrupt truncations in stratigraphy. Yet caution is required. Nature makes ordered things routinely. River terraces, fault scarps, and wave-cut benches can mimic engineered forms. The burden of proof would thus require patterns that are spatially extensive, geometrically precise beyond known natural processes, and accompanied by corroborative material evidence. Second are durable materials, metals, glass, ceramics, stone with tool marks that can survive burial. Metals corrode, but certain alloys and dense stone tools can remain relatively intact if quickly buried and shielded from oxidizing fluids. Ceramics, if vitrified and encased, can persist. However, plate tectonics complicates their survival. Burial under hundreds of meters of sediment followed by metamorphism can obliterate microstructures. Exposure at the surface invites erosion. A more likely durable trace would be large, in situ modifications to bedrock channels cut through rock. Mortared masonry of immense scale later silicified or mineralized by groundwater. Even here, though, natural origins must be excluded. Third are chemical signatures, isotopic anomalies, and molecular biomarkers that depart from expected baselines. Industrial processes rearrange elemental cycles in distinctive ways. A sustained, large-scale combustion of biomass or lithic fuels would leave a pulse in the carbon isotope record, an unusual depletion in 13C, for example, or an anomalous accumulation of inorganic trace elements such as heavy metals. Volumetric signatures, concentrated in well-dated strata, could be detected with high-resolution geochemistry. Yet natural events, volcanic outgassing, massive wildfires, methane hydrate release, also perturb carbon cycles. Interpreting an ancient isotopic excursion as the fingerprint of intelligence would demand patterns inconsistent with known. Natural drivers, stepwise changes in multiple elements, spatially synchronized anomalies across independent basins, and associated sedimentological evidence of deliberate landscape change. Fourth are molecular fossils, biomarkers, organic compounds that persist in sediment and can point to specific biological or technological processes. Certain complex molecules are unlikely to be produced by geology alone. Sterins and hopenaes have been used to infer biological inputs in ancient rocks. Synthetic molecules would be more definitive. But the chemical stability of most synthetic compounds is poor on geological timescales. The compounds more likely to remain are those that form recalcitrant macromolecular residues, graphitized hydrocarbons, or altered polymers. But distinguishing ancient synthetic residues from geogenic organics would be challenging and require multiple lines of corroboration. Even if such evidence were found, the narrator stresses the problem of false positives. Nature has a prodigious capacity for producing ordered complexity. Columnar jointing in basalt, symmetries in crystalline growth, concretionary formations, and biological biofilms can all present patterns that the mind tempted by narrative will read as intentional. Rigorous criteria, multiplicity of independent proxies, reproducibility, stratigraphic constraint, and the elimination of natural analogues must govern any claim. The history of science is littered with misinterpreted anomalies until better data and better models resolve them. How, then, might such a search be undertaken? The narrator sketches an approach that reads as both technical and poetic. Treat the planet like an overwhelmingly patient witness. Multidisciplinary teams would combine stratigraphy, geochronology, isotope geochemistry, sedimentology, and remote sensing to locate pockets where preservation is plausible. Ideal targets are those rare depositional environments that sequester material rapidly and then remain undisturbed, and noxic basins where organic rich layers accumulate, deep lacustrine beds that later lithify, and deltaic complexes that bury and protect. Offshore basins near passive margins carry thick sedimentary records and may hold horizons that, if broadly distributed and anomalous, warrant special attention. Subsurface geophysics and coring are the practical instruments of such an inquiry. High-resolution seismic profiling reveals buried paleolandscapes, terraces, and channels preserved beneath later deposits. Drilled cores let scientists read continuous sequences and extract chemical and microfossil records at high fidelity. If an isotopic or elemental anomaly appears synchronous across multiple cores, the signal gains strength. Spectroscopy, Raman, mass spectrometry, and gas chromatography can parse complex organics and discern molecular signatures that resist the usual diagenetic overprint. Yet technique alone is not sufficient. The narrator insists on intellectual humility. The absence of evidence is not evidence of absence, especially in a system that actively recycles its crust. But neither is imaginative appetite a substitute for empirical rigor. The history of geology itself offers cautionary tales, misreading of structures, the seduction of pattern recognition, and the temptation to project modern agency backward onto an indifferent planet. There is a different kind of evidence that is sometimes overlooked, continuity in biological lineages that suggests not only vicariance but long-term niche stability. If a technologically capable species arose and altered global biogeochemical cycles, those perturbations might have left footprints in the evolutionary record, sudden selective pressures, unusual extinctions, or shifts in community structure that do not align with known climate or tectonic drivers. Paleobiologists could, in theory, identify anomalous turnovers not readily explained by volcanism or impact. But ambiguity again looms large. Mass extinctions have multiple causes, and teasing apart anthropogenic-like signatures from natural ones is fraught with difficulty. The narrator expands this to a philosophical point. The deeper the time, the more the planet itself writes and rewrites. Sea floors vanish into the mantle, mountain roots are exposed and then shaved, sediments are recycled and transformed. For a hypothetical civilization to leave an unmistakable trace that survives hundreds of millions of years, that trace would have to be monumental, durable, and situated in a place unlikely to be recycled. Seldom conditions. The very improbability that makes the hypothesis alluring also makes it hard to test. And yet curiosity endures. In the margins, those places where life concentrated and where sediment accumulated, there are whispers of the past that modern tools can read. The interlocking evidence from rocks, fossils, and drifting mountain chains already tells a striking story about continuity among South America, Africa, and India, a shared biogeography born of unity and later severed by the patient violence of plate tectonics. The more speculative question, whether intelligence once rose and left its marks, turns the practice of geology into a forensic art. It asks of scientists not only to measure elements and dates, but to weigh probabilities, to differentiate the hand of nature from the hint of agency, and to accept ambiguity where the record is thin. The narrator closes the section with a tempered insistence on wonder. To read the similarities between continents is to witness time as a sculptor, to imagine the possibility of vanished intelligence, is to confront the limits of preservation and the resilience of evidence. Both inquiries require the same virtues: patience, rigorous method, and a willingness to be surprised. The planet stores both the passages of deep life and the outlines of its own processes. Sometimes it writes with clarity, sometimes in palimpsest. The real work is interpretive, to listen to the fragments and allow them to both enlarge and humble the human sense of history. In that space, the space between confident reconstruction and cautious speculation, curiosity remains the abiding practice. What disappears when a continent tears itself open? The question is not a simple catalogue of lost species, but a meditation on absence, on the kinds of living systems that dissolve. Under the slow machinery of plates and seas, and on the fragments those systems leave behind, sometimes preserved in exquisite detail, often reduced to chemical whispers. In the unmaking of Pangea, the planet did two things at once. It broke habitats apart, creating new theaters for evolution, and it erased or transformed contexts in which lineages had been thriving. Tracing what was lost is as much an exercise in geological forensics as it is in imagination, bounded by the constraints of what rocks can and cannot preserve. The first patent to register is that the breakup did not erase life evenly. Terrestrial and freshwater organisms were especially vulnerable to the geographic restructuring. Many taxa that depended on continuous river systems, broad floodplains, or climate belts found their ranges truncated by rising seas and newly formed oceanic barriers. The mechanism is vicarious. Ancestral populations divided by a newly formed barrier evolve on separate trajectories, sometimes surviving as distinct lineages, more often disappearing under local environmental pressures. For plants and small ground-bound animals, the sudden isolation of refugiate coastal shelves that became islands or basins that shifted in salinity meant extinction in some places and adaptation in others. The fossil record preserves those forks, sister taxa, appearing on opposite sides of modern oceans, their divergence dated to the window of rifting. But not all losses are the consequence of simple separation. Rifting is often accompanied by volcanic and magmatic episodes, large igneous provinces, flood basalts, and pulses of aerosols into the atmosphere. Those events, sometimes synchronous with the opening of ocean basins, could perturb climate, trigger wildfires, acidify soils, and alter ocean chemistry. In certain intervals of the rifted past, these environmental blows coincided with high rates of turnover. Species that had already been stressed by habitat fragmentation were pushed over thresholds. The geological record links some of the most dramatic biological reorganizations to episodes that trace back to tectonic unrest. In this way, breakup is both a sculptor of new biogeographic boundaries and an agent of mortality. Yet the notion of something being erased entirely underestimates the planet's capacity to conserve information, if only in partial, transformable forms. Many of the organisms that disappeared did not vanish without trace. They left impressions in shorelines that were buried and later lithified, teeth and bones encased in deltas that were then subsumed into deeper sedimentary basins, and chemical anomalies that register in isotopes. Fossil beds on passive margins, those thick wedges of sediment that accumulate where a rifted continent becomes a slow sinking shelf, are often where the story survives most vividly. Rapid burial in deltas or during storm-driven turbidity currents can yield extraordinary preservation. Articulated skeletons, imprints of vegetation, and even soft tissues preserved under anoxic conditions. These archives are windows back into ecosystems that existed just before and during the opening of new ocean basins. The sea itself becomes both a preserver and an eraser. In places where subsidence created anoxic basins, organic matter accumulated in black shales. These are carbon-rich pages in which biochemical fingerprints can remain for hundreds of millions of years. In other settings, powerful turbidity currents buried coastal forests and reefs in turbid fans on the abyssal plain, creating pockets of preservation that later geologists and paleobiologists can read. Conversely, much of the oceanic crust, the literal floor of those newly forming seas, is destined for destruction. Mid-ocean crust is ephemeral on geological timescales. It is created at ridges and eaten at trenches. Where life was mostly seafloor bound on that transitory crust, its direct physical archive is largely gone, swallowed into the mantle long before any human curiosity could retrieve it. There are also particular modes of preservation that matter when considering what might have been lost with Pangea's disassembly. Ophiolites, Fragments of ancient oceanic crust emplaced onto continents during collision can carry snapshots of seafloor, communities, and the chemistry of ancient vents. Accreted terrains preserve pieces of ocean basins that escaped subduction and were welded onto continental margins. Glacial tills and striations carry evidence of climatic episodes tied to continental positions. Paleosols buried ancient soils, bear signatures of vegetation, atmospheric composition, and even wildfire regimes. Forensic geologists read these layers not as complete narratives but as palimpsests, some pages clear, others smeared. The aggregate is seldom sufficient to reconstruct a living tableau in micro-detail, but together these clues can reconstruct trends, shifts in precipitation patterns, episodes of marine transgression, pulses of volcanism that explain the fate of many lineages. Beyond macroscopic fossils and strata lie subtler archives, isotopic ratios, trace metals, and molecular fossils. Carbon isotopes can record changes in primary productivity and the burial of organic matter. Elevated mercury or certain trace metal enrichments can indicate volcanic episodes that would have stressed ecosystems. Biomarkers, molecular residues from organisms, can persist in sedimentary kerogens, offering fingerprints of groups that left few hard parts. These chemical signatures are often distributed across multiple basins when correlated in time. They point to global or regional events that shaped extinction and speciation patterns. In the context of Pangea's breakup, such signals are invaluable because they can reveal environmental shifts even where bones and leaves are absent. This interplay between erasure and preservation shapes a second question. Could deep time traces, huge geomorphological modifications, chemical footprints have been left behind that only now lie under kilometers of ocean? The short answer is yes, but with heavy caveats. The deep ocean hides thick stratigraphic successions, turbidite fans, deep marine shales, and buried canyons that once received the fluvial sediments of continental rivers. In certain locales, rapid subsidence and high sediment flux can lock away evidence almost intact. If an exceptional geomorphic feature, an engineered terrace of bedrock, or an unusually regular linear channel were cut into stable crust and then quickly buried in an anoxic basin, there is a non-zero chance it could survive as an anomalous stratigraphic signal. But nature is adept at making order look like artifice. Distinguishing a true anomaly from a geologic process requires multiple, converging proxies, not imagination alone. The search for those submerged histories is therefore both empirical and philosophical. It rests on the science of detection, seismic imaging that can reveal buried terraces and channels, coring programs that can extract continuous records, and geochemical analysis that can map unusual isotopic excursions. It also rests on restraint, an unwillingness to leap from an anomalous pattern to the narrative of agency without rigorous elimination of natural mechanisms. The rocks contain stories both of life and of process. The historian's task is to separate author from stagehand. That sense of restraint is vital as the narrative pivots to a more speculative exercise, imagining a world in which Pangea never split. What if the seams never widened? If the plate movements that pried continents apart had never taken the particular courses they did? What would the climate look like, and what would be the consequences for life and for the long arc of planetary habitability? The thought experiment begins with a simple observation about geometry. A single massive land area changes the rules of atmospheric and oceanic circulation. In a world where one continuous continent hubbed a single ocean, Panthalassa, unbroken, the distribution of heat, moisture, and wind would be reorganized. The elemental dichotomy that once characterized Pangea's interior and rim would persist, but the scale of each regime would be magnified and its connectivity altered. First, the interior. Size still breeds extremes. A continental heart hundreds of millions of square kilometers across would remain torso-like in its climate. Snow and rain at high latitudes and altitudes, but vast regions far from the marine moisture would experience prolonged aridity, without fragmentary coastlines delivering localized moisture. The interior would still be hostage to long, dry seasons and colossal temperature swings. Rivers would still run the length of continental gradients, but many might remain endorheic, terminating in inland basins rather than finding an emergent ocean outlet, producing vast salt flats and evaporite deposits, the image of a super desert punctuated by corridor oases and glacier-fed rivers is likely to endure. Rim climates, however, would be where the most dynamic meteorology occurs. A continuous shoreline facing a single vast ocean would be a theater for powerful monsoonal systems. Land heats and cools faster than water. A continental rim of unprecedented breadth would drive seasonal pressure differences so large that entire sides of the supercontinent might breathe in unison, an ocean basin-scale monsoon. Coastlines would experience episodic torrents, runoff pulses, and rapid deltaic growth. Those margins would be ecological engines, rich deltas, mangrove-like forests, and nutrient-rich shells where marine and terrestrial productivity concentrate. In essence, habitability would be bundled at the edges and threaded along great river corridors that transport the elemental wealth of the continent to its rims. Ocean circulation, crucially, would be different. Modern patterns, the Atlantic meridional overturning, the constricted gateways between basins, the narrow straits that mediate heat transport are products of continents arranged as they currently are. A single encircling panthalassa would allow enormous persistent gyres, and the relative absence of interior seaways would alter poleward heat transport. Whether the poles would be relatively warmer or cooler depends on the specifics of wind forcing and the presence of circumpolar currents, but overall, the thermal inertia of a single ocean might have reduced latitudinal gradients in some eras and accentuated stratification in others. Regions of persistent upwelling could sustain mega blooms and rich fisheries along the rim, while large, stagnant basins might foster oxygen-poor conditions in deeper waters. From a biodiversity standpoint, the consequences are striking and counterintuitive. Continental fragmentation increases endemism by isolating populations and fostering divergent evolution. If Pangea had never broken, those repeated opportunities for allopatric speciation would be fewer, and global biodiversity patterns might be less partitioned by distinct provinces. On the other hand, a contiguous landmass offers extensive continuous habitats, allowing some clades to achieve enormous geographic ranges and to evolve large-bodied and wide-ranging life strategies. The evolutionary recipe thus shifts, fewer insular radiations perhaps, but more widespread generalists and a different balance of diversity between coastal refugia and continental halls. Human scale implications, considered as systemic tendencies rather than narratives of particular people, would also be profound. Migration corridors would be terrestrial rather than maritime in many places. Trade routes would flow overland along rivers, and across steppe corridors, the concentration of ports and fisheries would be bunched along an unbroken rim rather than distributed among many continental shelves. Resource distribution would differ. Hydrocarbon deposits, which form under particular sedimentary and depositional regimes, might be concentrated in fewer but larger basins. The absence of many modern passive margins could change where energy resources concentrate and how accessible they are. Yet this speculative Pangea is not a static utopia. The same tectonic forces that stitch and suture also drive orogenic uplift, volcanism, and subsidence. Mountains would still rise, deserts would still march, and seas would still invade lowlands under changing sea levels. The planet's dynamism would ensure that change, rather than stasis, defined the long view. The ethical contour of this counterfactual is not nostalgia but perspective. Imagining Pangea remaining into the present is a tool for understanding contingency, a way to see how the geometry of land and sea prescribes the corridors of climate, the scaffolding of ecosystems, and the broad outlines of evolutionary possibility. It reminds the listener that modern distributions of life, resources, and even human cultural patterns are accidents of plate motions writ large. Returning from speculation to the archive, the narrator insists on a posture of methodical humility. The story of life in the era of Pangea is not a closed book, but a layered ledger. The rifts erased and preserved in equal measure. Some lineages vanished under the joint stresses of fragmentation and volcanic pulses. Others were carried along the currents of new seas, their descendants recognizable in distant coasts today. The ocean hid vast swaths of that history beneath basalt and trench, but it also preserved pockets where rapid burial and anoxia kept delicate structures intact. Modern science reads these fragments like a person reading faint handwriting in the margins of a manuscript, reconstructing narrative from cues, attentive to the difference between what is certainly written and what might be an artifact of the page's decay. Ultimately, the lesson is not one of loss alone, but of relationship. Pangea's breakup was an act of planetary self-reconfiguration. It rearranged the possibilities of climate and life, opened corridors of novelty, and erased entire chapters that might otherwise have continued. What survives is a mosaic of bones, stones, isotopes, and organic residues, each fragment a testimony to both continuity and rupture. To study those fragments is to practice patience at the scale of deep time, to listen closely to the rock, to measure chemical murmurs, and to embrace ambiguity as the proper companion to curiosity. In that listening lies the real invitation to accept that Earth's history is vast, often opaque, and forever generous to those who learn to read its layered script. What does it mean to inherit a continent that no longer exists? The question arrives like a small, insoluble knot in the mind. Not an invitation to nostalgia, but an insistence that a planet writes itself into living things. The memory of Pangea is not idle history. It is a network of seams and echoes folded into rocks and rivers, embedded in genomes, and woven into the pathways by which life, and by extension human societies, move, compete, and remember. To listen to that memory is to hear how ancient geography continues to shape politics, migration, ecology, and economies long after the land itself has been torn apart. The first trace of Pangea is visible in stone. Geological sutures are like scar tissue from a body's healed wound. Orogenic belts that once stitched continents together still carry the age and pressure of those collisions. Where rock types line up across oceans, where zircon crystals mirror each other's histories, there is an argument for continuity. Those arguments are not merely academic, they are the foundations of modern landscapes that humans inhabit. Mountain chains, born in the assembly of Pangea, still channel monsoon winds, still cast rain shadows into deserts, still determine where rivers cut fertile valleys and where soils accumulate. The very borders that have guided migrations and demarcated political territories are, in many cases, written first by the patient hand of tectonics. A modern boundary drawn along a ridge or a river is ultimately an echo of stresses and sutures that predate the species that drew the map. Memory in rocks translates into memory in water. River systems follow the topography sculpted by ancient orogenic events and rifting episodes. Drainage basins are inherited architectures, a tributary fed by meltwater off an uplifted belt, a delta built on sediment shed from eroding mountains, an inland basin where a river dies in a salt flat. These hydrological legacies are not just physical facts, they shape livelihoods. Where rivers concentrate nutrients, agriculture follows. Where they fracture into distributary networks, ports and trade routes later appear. The sediments deposited on rift margin shelves would, after long burial, form reservoirs of energy, peat into coal, organic rich shales into hydrocarbons, resources that would become engines of modern economies centuries of human effort later. In this sense, Pangea's breakup reaches forward through time, arranging the geographies of wealth and scarcity that determine geopolitical alignments. But the memory is not only geomorphic or economic, it is biological and molecular. Life bears the imprint of former continuities, the biogeographic patterns that puzzled 19th century naturalists, the presence of near-identical Gondwanan flora across southern continents. The curious distribution of freshwater reptiles in now-distant basins are not anomalies but signatures of a world once whole. Lineages split and diverged as land masses drifted apart. Sister clades, now separated by oceans, testify to a history in which migration happened on foot, not by raft. DNA carries these separations as temporal distances measured in mutations and molecular clocks. The genetic maps of many clades are, in effect, palimpsests, overlays of vicariance and dispersal written into the structure of genomes. This genetic memory does more than chart past connections. It shapes resilience and vulnerability in the present. Populations that evolved across broad, continuous habitats may have high genetic variance suited to diverse conditions. Others, that entered insular refugia during breakup, may have retained narrow adaptations. Those patterns influence how species respond to rapid environmental change. Endemism that grew from isolation becomes a liability when climate shifts or new competitors arrive. Widespread generalists, favored by a once unified landscape, may prove more robust. In ecological communities, the ghost of Pangea informs who can expand when a corridor reopens, who gets stranded when a seaway closes, and which clades are poised to radiate when disturbance opens niches. Even the microscopic world carries traces. Microbial lineages tied to particular soil chemistries or to the hydrothermal chemistry of ancient ocean margins have histories that link them across continents. Biomarkers preserved in sediments, molecular fossils offer fingerprints of metabolic pathways that once flourished in specific chemical milieux. The subtle chemistry of carbon isotopes and trace elements can reveal pulses of productivity or oxygen depletion tied to tectonic events. Those chemical echoes are the planet's slow time memory, readable to the patient instruments of geology and geochemistry. This interlacing of geology and biology bends the arc of migration in surprising ways. Human movement, too, has been channeled by topography that itself is a memory. Mountain passes that allow human dispersal are the product of uplift and erosion. Plains that enable early agriculture began as filled basins or eroded forelands, coastlines, favorable for settlement, owe their geometry to passive margin development and sedimentation. The grand routes of human migration, overland corridors, coastal pathways, riverine highways are often superimposed upon a skeleton shaped by tectonics. When climate pressure forces migrations, the choices open to people are not abstract. They are bounded by ancient drainage divides, by deserts that are the rain shadows of old ranges, by coasts where storm regimes are governed by continental-scale ocean currents that themselves were reconfigured by breakup. There is a political dimension to this inherited geography. States, jurisdictions, and conflicts often follow the contours of land that were set into motion millions of years ago. Resource endowments, mineral belts, fertile basins, offshore petroleum cluster in patterns legible as the residue of rift basins and passive margins. Control of those resources becomes a foundation for economic power and geopolitical friction. In this way, Pangea's memory underwrites modern governance problems, the uneven distribution of natural wealth, the tension over access to coasts and rivers, the ecological consequences of extracting deep-time stores of carbon. The planet's ancient geometry has a way of setting the terms of human politics by arranging the raw materials from which societies build power. Yet memory works in subtler cultural ways as well. Place names, myths, and narratives sometimes encode older geographies in the body of cultural memory. Legends of great floods, of sea lands swallowed by water, of ancestral homelands accessible on foot may capture, in compressed form, experiences of sea level rise or the closing and opening of seaways. Storage can be repositories of environmental legacy, compressed chronicles of changes in coastlines and climates that, redistributed across generations, help communities adapt. In many coastal and island cultures, oral histories preserve accounts of shifting shores and lost lagoons that mirror the kinds of processes that sculpted Pangea's margins at a different temporal scale. These narratives are not precise maps, but they are part of the palimpsest of memory, human ways of remembering environmental change that complement the slow, dry testimony of rock. The memory of Pangea also reframes how modern planners might think about migration and ecology. Consider the concept of ecological corridors, deliberate attempts to reconnect habitats fragmented by human infrastructure. There is a parallel between these contemporary projects and the ancient processes that once connected continents. The long-term lesson is that connectivity matters. Corridors permit gene flow, buffer populations against localized extinction, and enable range shifts in response to climate change. If Pangea teaches anything in this register, it is that when connectivity is lost, evolutionary pathways diverge. When it is restored, possibilities reopen. For a species facing rapid anthropogenic change, the ability to move matters as much as the ability to adapt. There is an uncomfortable irony here. Fossil fuels, the concentrated remnants of ancient biomes preserved in rifted basins and passive margins, have driven modern industrial societies. The very geological processes that created concentrated stores of organic carbon, swampy margins buried and transformed, are the source of a global energy economy that now threatens to alter climate at planetary scale. Pangea's gift of buried energy thus becomes a modern agent of disruption. The release of carbon stored over deep time now forces ecological and political systems to respond across human timescales. Memory, in this case, has consequences that invert expectation, the distant past shaping immediate crisis. A speculative image helps to gather these threads. Imagine a single thread running through time, tying mountain route to modern river delta, to a nation's breadbasket, to a global market. The thread begins in the crustal collision that raised a range. Sediment eroded from that range, fed a basin that became rich in organics, which centuries later supported agriculture, industry, and political consolidation. The thread is Pangea's memory, a long causative chain between deep tectonic events and contemporary human affairs. Understanding that chain is not merely geological curiosity, it is a form of historical literacy that situates human decisions within a planetary narrative. The memory also frames how societies might conceive of migration in the near future. As climates shift, as sea levels rise and storm tracks alter, human migrations will follow corridors that geology has already defined. Cities perched on stable shelves may be more resilient than those on narrow, subsiding coasts. Agricultural regions dependent on monsoon belts, which themselves are sensitive to ocean geometry and climate forcing, may experience shifts that push populations to move along ancient river corridors or into upland refugia. Those movements will carry cultural and genetic lineages into new assemblages, reconfiguring ecosystems and political territories alike. The ancient geometry thus becomes a predictive element. Knowing how current landscapes arose can inform the likely paths of future displacement and adaptation. This is not to anthropomorphize deep time into destiny. Plate tectonics provides constraints and scaffolding. It does not prescribe human moral choices. Yet awareness of those constraints matters. Infrastructure investments that ignore the sedimentary history beneath a city building on river deltas that are recent and dynamic, for example, may be fragile in the face of sea level rise or subsidence. Policies that fail to account for the inherited distribution of resources and ecological refugia risk repeating patterns of inequity embedded in the planet's geology. To read Pangea's memory is therefore to adopt a time-scale sensitive prudence, to plan with an eye for deep legacy and future contingency. There is a cognitive dimension to this kind of prudence. Understanding deep time legacies encourages a different relationship to the present. Humility. A landscape that seems fixed to a generation is in reality a transient arrangement in a much longer movie. That humility is not paralyzing, it is clarifying. It reframes economic forecasts, conservation strategies, and geopolitical thinking by reminding actors that the substrate beneath their decisions is itself a moving story. The recognition that the very terms of habitability, climate belts, water distribution, soil fertility were authored in part by the long history of tectonics invites policies that are adaptive, flexible, and attentive to place. Finally, there is an ethical resonance to carry. Pangea's memory shows that the Earth's story is continuous. Human history is a brief, intense chapter inscribed on a much older, patient narrative. This sense of continuity does not diminish responsibility, rather it expands it. To burn ancient carbon is to accelerate a chapter of planetary change that took millions of years to write. To fragment ecosystems further is to sever threads that took geologic forces to weave. If Pangea's legacy is a library of long-term consequences, then stewardship becomes an act of reading carefully and answering responsibly. The narrator's voice gathers in the final reflection, still third person and still omniscient, urging a patient kind of curiosity. In rocks and genes, in coasts and currents, Pangea's memory persists. It is a network of constraints and affordances that reaches across time to shape politics, migration, and ecology today. To acknowledge that is not to surrender to inevitability, but to recognize the scale of the canvas on which human agency paints. The lesson is both practical and philosophical. The planet remembers, and through that memory it speaks back to those who would plan, conserve, migrate, or govern. Listening to that speech requires tools: geology, genetics, climatology, and virtues, patience, humility, and an appetite for the slow and strange logics that have always authored Earth's surface. In those combined acts of attention, the memory of Pangea becomes less a relic and more a guide, a deep-time counsel for the choices that will shape the next chapters of life on a planet that is forever making and unmaking itself. What would it mean, the narrative asks in its final cadence, for Pangea to be not merely a geological hypothesis, but a living memory folded into every field and city that people now call home? That question opens the conclusion like a small, sharp lens, concentrating themes that have been traced across plates, seas, and time into a single observation. Humanity, in its distribution, its cultures, and its economies, exists on the flaked edges of an older unity. Humans are fragments of a whole that once was, ecological, geographic, and climatic, and that persistence of the past, though broken and reworked, continues to shape the present. The continent that gathered has been cut into pieces, yet, in ways both blunt and subtle, it has never entirely vanished. The image that guides this section is deliberately simple and slightly disorienting. Imagine holding a shard of pottery under a light and seeing, in the glaze and craze lines, the echo of the entire vessel. The shard's silhouette tells a story of a bowl that once contained a household's life. The glaze pattern hints at aesthetic choices. The crazing betrays temperature and handling. From a single piece, it is possible to infer the form of the whole imperfectly, with holes in conjecture, but possible nonetheless. Modern continents are shards. The mountain roots, the passive margins, the DNA of plants and animals are the glazes and craze lines. They do not reconstruct Pangea perfectly. They do not bring back the ocean that circled it or the deserts that lay in its heart. But they are the memory of that vessel, and memory is a real force. The narrative voice here leans into a tone that is both awestruck and chastened. There is a humility in recognizing that the human habit of imagining continuity, maps, borders, habitual roots, sits atop a far deeper continuity of rock and climate. The aridity suggested by the phrase Pangea dry acts as both metaphor and fact. The supercontinent's interior, held far from the moderating influence of oceans, became a region of extremes, vast seasonal swings, monsoonal surges that sometimes penetrated far inland, and extended periods of drought where rivers failed to reach an open sea. That long-run scarcity, root across millions of years, left patterns in sediment, pockets of preserved life, and a geography that would later constrain migration and resource allocation in ways no single human generation could foresee. In the practical terms of settlement and survival, the result was concentration. Life clustered at the margins along coasts, river systems, and fertile basins where moisture, nutrients, and shelter were more predictably available. Those are the places where the fossil record is richest, where coal seams and carbonate platforms accumulated, and where, much later, human societies would find concentrated resources to mine. It is a telling irony. The same processes that made certain strips of land extraordinarily productive on geological timescales, delta building, peat accumulation, and NISI, long-term burial of organic matter under anoxic conditions, are the reasons modern civilizations discovered, extracted, and ultimately burned the stored energy of deep time. The unbroken ocean and the great rim of Pangea concentrated life at a planetary scale and thereby concentrated the raw materials of future economies. This tension between ancient concentration and modern consumption carries an ethical weight. The sedimentary basins of rifted margins, once slow repositories of carbon, are now reopened and emptied in decades. The narrative does not moralize in the sense of accusing natural processes, but it does emphasize the dissonance of temporal scales. What took millions of years to bury can be liberated in a human blink. That liberation reshapes climate and shifts oceanic chemistry, the very systems that once shaped Pangea's climates and its margins. The planet's long memory, therefore, is not merely historical, it is causal. The sedimentary ledger written by swamps and shallow seas becomes an active participant in present climate dynamics when that carbon is released. The memory of Pangea thus reaches forward in time to become part of the material cause of contemporary planetary change. At the same time, the voice stresses resilience and persistence. Pangea's traces are not only energetic liabilities, they are also ecological foundations. Soils derived from ancient sedimentary and igneous processes underwrite agriculture in river plains once formed by mountain uplift and erosion. River corridors shaped by rift basins and fallen basins provide routes for migration, commerce, and cultural exchange. The distribution of mineral resources, ore belts, sediment-hosted deposits, and hydrocarbon provinces follows tectonic histories that extend back to sutures and rifts. These legacies organize economies and politics. In many parts of the world, the location of wealth, the placement of cities, and even the contours of conflict map, bizarrely and inevitably, onto events that unfolded hundreds of millions of years ago. This is not to imply determinism. Plate tectonics does not decree human decisions, nor does ancient geography serve as a strict script. What it does provide is constraint and affordance, scaffolding on which human choices play out. Where a broad shelf accumulates sediment, a fertile delta may develop. Where a mountain belt channels moisture, a corridor of biodiversity and human movement might persist. Where a passive margin hides thick organic rich shales, a modern energy economy may arise. The interplay between constraint and freedom is central to the final claim. Pangea, though broken, is still a kind of stage. The actors, the living species and human societies now improvise on that stage, sometimes with creativity, sometimes with inadvertent destructive force. The narration widens the frame to consider cultural memory and myth as complementary repositories of deep time awareness. Oral traditions, ancient flood legends, and myths of sunken lands often carry forms that mirror environmental change. These narratives are not geological accounts, but they are cultural responses to shifting shorelines, changing river courses, and climatic stress. In several coastal cultures, stories of drowned villages, migrating lagoons, and ancestral homelands accessible by foot echo the kinds of geographic transformations that unfold when sea level rises or when tectonic tilting reconfigures coasts. Such myths, when read alongside stratigraphy and paleoclimate, provide a fuller sense of how humans perceive and adapt to shifting geographies. They are another form of memory, less precise than isotopes perhaps, but potent in guiding behavior and preserving lessons. The narrator returns, with deliberate quiet, to the theme of preservation bias, this time not only as a scientific fact, but as a social lesson. The places where records are richest shelves, deltaic basins, and floodplain deposits are also the places most subject to human exploitation. Civilization arose in these same places because they were rich in water, soil, and minerals. Thus, the archives of deep time and the engines of modern development are co-located. The paradox is that the very abundance that allows for archival preservation also leads to disturbance. Urban growth, resource extraction, and agricultural conversion often obscure or destroy the paleontological and geological records beneath or beside them. The planet's memory, in other words, is fragile in practice, even where it seems robust in theory. The conclusion develops a sustained reflection on responsibility. To read the archive of Pangea requires a particular kind of attention, patience, technical skill, and interpretive humility, but it also demands an ethical stance. If human activity mobilizes stores of deep-time carbon and thereby alters the planetary systems that made life possible, then knowledge of those systems carries an obligation to act with foresight. The narrator does not prescribe policy, but frames a moral question. What obligations arise from understanding that contemporary prosperity rests on the slow work of ancient ecologies? Recognizing that the coal seams and petroleum reservoirs are not simply resources, but the compressed remains of whole ecologies, reorients the meaning of extraction. It reframes economy as a conversation across time, a conversation that, if one listens, reveals both gifts and costs. Attention then turns to the methodological humility needed to read Pangea's continuing influence on human geography. The tools are familiar: paleomagnetism, stratigraphy, sedimentology, molecular paleontology, but their application must be guided by an awareness of bias and incompleteness. Where sedimentary layers speak confidently of river courses and monsoon regimes, they do so in a language of average signal, the superimposition of many episodes into a conglomerate story. Interpreting these signals for present-day planning, where to build, where to retreat, which corridors to preserve, requires integrating geological timescales with human timescales in policy, infrastructure, and conservation. That integration is not trivial. It requires institutions that can hold multiple temporal perspectives and translate them into practical action. The voice lingers over a counterfactual exercise, not because it indulges in fantasy, but because counterfactuals sharpen understanding. What if Pangea had remained unbroken? The continent's interior would still have been vast and arid. The rim would still have concentrated life. Migration corridors and economic hubs might have different configurations, but the same underlying logic edges as abundance, interiors as austerity, would persist. The point of this thought experiment is to reveal contingency rather than inevitability. The modern map is one of many possible outcomes produced by plate tectonics, orbital forcing, and chance. That recognition breeds a form of cognitive freedom. Knowing that the present arrangement is contingent invites a humility toward attempts at grand control and an openness to adaptability. At the end of the piece, the narrator tightens into a more intimate register. The fragment metaphor reappears, but with another twist. Shards can be reassembled into a provisional picture, and the act of reassembly is itself instructive. Modern science, through paleogeographic reconstructions, is an act of such assembly. It does not restore Pangea intact. It offers models, maps animated over millions of years, that reveal how continents migrated, how oceans reconfigured, and how climates shifted. These reconstructions are not only explanatory tools for scientists, they are cognitive instruments for society. They help place human decisions within a broader narrative of planetary transformation. The final paragraphs adopt a more spoken rhythm, as if closing a documentary with both a charge and a benediction. Pangea's legacy is double-faced. It is both an archive of what was and a set of material conditions that shape what is. The shards underfoot, the shelves, the mountain roots, the DNA signatures are not inert evidence. They are active shaping forces. To walk upon them is to be in conversation with a planet that remembers. The appropriate response, the narration suggests, is a mixed posture of curiosity and restraint. Curiosity leads to better maps, to more refined reconstructions, to the patient reading of sediments and isotopes. Restraint asks that knowledge to guide choices, conserving corridors where biodiversity can shift, recognizing that buried carbon was once living complexity, planning settlements with an eye to ancient and future dynamics of water and sediment. The story closes with an image that is meant to sit in the listener's mind like a small stone in the hand. Imagine an ancient shore, long buried, whose sands now rest as sediment in a delta. That delta feeds a river whose water irrigates crops, whose sediments build soil, and whose banks support cities. The sediment was once part of a single supercontinent. The chain from Pangea's mountain to a modern field is not merely temporal, it is causal and intimate. In that chain lies both the continuity of the planet and the ethical horizons of human responsibility. Pangea may have been broken into many lands, but in the fragments, dry basins, coastal shells, mountain stumps, its presence endures. It is a presence that asks to be read carefully, acted upon wisely, and remembered with the humility befitting creatures whose lifetimes are brief against the deep rhythms of earth. An idea opens this final chapter like a slow, uncompromising lens. Pangea is not merely an episode of rock and plate, it is the opening chapter of the earth that modern life inherited. That thought asks the listener to shift perspective from discrete facts, the names of seas, the timing of rifts, to a story of causation that runs from deep tectonics to the shape of contemporary climates, ecosystems, economies, and ethical choices. It insists that the unmaking of a single colossal landmass set in motion, a sequence of arrangements and imbalances that continue to determine what is possible on the planet. Seen this way, Pangea is less a curiosity of paleogeography and more the prologue to the conditions that made the modern world intelligible. The voice in this closing sequence remains omniscient, careful, and intentionally reflective. It draws threads through the previous chapters and tightens them into a single thesis. The geometry of land and sea that Pangea established and the way it fractured authored not only sedimentary archives and fossil lineages, but the scaffolding of atmospheric circulation, of nutrient fluxes, and of long-term carbon sequestration. Those processes, amplified and rearranged by rifting and ocean opening, wrote the rules of habitability, and some of the most consequential rules are those most invisible to daily life. Consider the large, simple fact of concentration. Pangea's existence concentrated moisture and life at the rim, and concentrated aridity and endurance in the interior. That spatial bias shaped where biomass accumulated through coal-forming swamps, where carbonate factories built shelves and reefs, and where deltas and estuaries became cradles of biodiversity. Those concentrated archives are the very stores modern industry would later discover as resources, seams of coal, thick organic shales, and prolific hydrocarbon basins. The planet's slow habit of turning living abundance into buried stores is at once creation and archive. It is an economy of deep time, photosynthesis, burial, and diagenesis store energy for epochs. Plate tectonics then distributes and preserves, sometimes obliterating, sometimes conserving those concentrated stores. When modern technology taps those deposits, it is not only extracting fuel, but reopening a geological ledger written over millions of years. That causal chain, mountain uplift to erosion, to deltaation, to burial, to fuel, illustrates why Pangea can be read as a starting chapter. The tectonic choreography of assembly and breakup produced margins where organic matter was sequestered at scales rarely rivaled since. Those margins turned into the economic endowments of later millennia. The enormous irony is stark. The planet's patient economy of sequestration became, in a human instant, the engine of a disruptive global economy. In this way, Pangea's geology, its folds and basins, its rifts and shells, stepped forward as an agent shaping human history. But the legacy is not only energetic, it is biogeographic. The breakup of Pangea rerouted patterns of dispersal, set the stage for vicariance, and created the provinces of life that paleontologists and biogeographers read today. The same fossil signatures found in Gondwana's coal and glacial tills are not relics, only of antiquarian interest. They are evidence of living distributions controlled by a former unity of land. Genetic lineages, too, carry this imprint. Molecular clocks, when cross-referenced with paleogeography, reveal temporal separations that mirror rifting events. The fragmentation of ranges caused by seas that were once corridors, or, conversely, barriers, is a logic that persists in the DNA of many living groups. Pangea's breakup wrote evolutionary experiments into isolation and reconnection, experiments still legible when genomes and fossils are read together. There is also a climate argument that makes Pangea a foundational chapter of modern Earth. The opening and closing of seaways, the rearrangement of Panthalassa by nascent oceans like the Proto-Atlantic, the contraction and transformation of Tethys rewired oceanic and atmospheric circulation. Those reorganizations altered heat transport, upwelling regimes, and the position and intensity of monsoonal belts. The placement of mountain belts formed rain shadows and directed moisture corridors. The subsidence of rifted margins allowed new shelves to form that would change coastal productivity and carbon burial. In aggregate, these shifts modulated global carbon cycles, oxygenation events, and the conditions under which mass extinctions and radiations occurred. Put plainly, the tectonic acts that tore Pangea apart were not mere geography, they were planetary-scale climate experiments, whose results endured for tens of millions of years. The narrative does not romanticize those acts. The same tectonics that created opportunity also created catastrophe, volcanic provinces that dimmed sunlight, anoxic basins that replaced oxygenated seas, climatic swings that pruned lineages. The metaphor here is not judgmental but mechanical. Earth's internal engines drive surface conditions. The human lesson embedded in that mechanical fact is humility. Modern decision-making increasingly touches planetary parameters, atmospheric composition, ocean chemistry. Yet those are precisely the variables that geology has been modulating across deep time. Recognizing Pangea as the opening chapter in a continuing book encourages a view of stewardship that incorporates deep cause and delayed consequence. This chapter also presses on method. If Pangea is an opening act, then reconstructing its narrative requires a set of techniques that read the planet's long handwriting. Paleomagnetism gives latitude histories, stratigraphy aligns sequences across shelves and passive margins, isotopic chemistry reads changes in carbon and oxygen, trace metals and biomarkers whisper the presence of past productivity or volcanism. Seismic reflection peels back buried landscapes, revealing channels and terraces that once flowed as rivers or formed as coasts. Coring retrieves continuous records of chemistry and microfossils. Each method is, in a sense, an instrument for listening, a way to recover the cadence of events when the planet feels too slow for immediate comprehension. Yet the interpreter must remember that the archive is partial and biased. Preservation favors the margins, it disfavors ephemeral shorelines and mobile biotes on seafloor that will plunge into trenches. The planet is simultaneously generous and miserly. The geological record preserves grand architecture, mountain seams, broad basins, and major extinction horizons, yet it often erases the small details that might satisfy narrative curiosity. A short-lived cultural imprint, a transitory shoreline, a brief ecological assemblage at a particular latitude. The proper posture toward deep time therefore combines technical patience with interpretive restraint, curiosity married to caution. That restraint extends into speculative questions that hover at the edge of evidence. Previous parts of the narrative invited imagination. Could agency have left traces in deep time, but always under careful skepticism? The logic that follows remains. Radical claims require radical evidence. If Pangea is the opening chapter, then any hypothesis about unusual events within that chapter, unrecorded intelligences, artificial constructs, or extraordinary disturbances must be tested against the planet's known mechanisms of creation and erasure. Durable anomalies would need to survive burial, metamorphism, and plate recycling, an inherently unlikely combination. It is a sobering constraint and a methodological guardrail against the seduction of appealing stories that outpace their evidence. There is, however, a constructive speculative limit that should not be dismissed. The idea of reading chemical and isotopic anomalies as signals of atypical processes, large, sustained perturbations in carbon isotopes, unusual concentrations of trace elements, synchronous anomalies across multiple basins, these are the sorts of signals that invite harder interrogation. The cautious scientist does not leap to agency. They ask instead whether combined natural mechanisms can account for such perturbations. The power of this approach is that it converts imaginative questions into testable hypotheses, allowing speculation to be disciplined rather than fanciful. Returning from method to consequence, the chapter broadens to the human scale once more. Pangea's ancient geometry underlies modern distributions of resources and risk. Sedimentary basins that formed on rifted margins hold hydrocarbons. Soils derived from eroded mountain chains underpin agriculture. Coastlines shaped by passive margin subsidence govern modern port locations and exposure to storm surge. Human geopolitics, in turn, becomes a late-acting consequence of deep geological history. Borders that seem historical in human terms are often downstream products of millions of years of uplift and erosion. Regions of abundance, fertile deltas, mineral-rich belts were made possible by Pangea's long scripts. To understand present inequities and vulnerabilities is to read them on a geological ledger that predates human institutions. That reading carries an ethical dimension. Knowledge that a particular coastal community occupies a delta formed by Pangea-era basins is not merely interesting, it matters. For planning undersea level rise, understanding that a nation's fossil fuel wealth rests on burial of ancient swamps implicates deep time legacies and contemporary climate trajectories. The narrator resists grand prescriptions but emphasizes a moral urgency. The planet's slow history confers responsibilities. Stewardship should be informed by the recognition that human actions now alter processes that geology has been modulating for eons. Finally, the chapter circles back to the smallness and intimacy promised in the opening. The image returns, a shard of pottery under light, its glaze betraying the whole vessel. Modern continents are shards of a former whole, and their seams and stains contain the memory of a planet's youthful unity. To live on those shards without ever looking back at the vessel from which they came is to accept a truncated story, one of local, detail divorced from planetary causality. The final, insistently humble question thus returns and reframes itself. If humanity has never looked back to see the world when its land lay whole, can it claim full understanding of the place it occupies now? There is no simple answer, and perhaps that is the point. Understanding the world is not a finite achievement, but an ongoing practice of curiosity, measurement, and reflection. Pangea's role as the opening chapter is both an explanatory device and an ethical prompt. It asks observers to read the present as an effect as much as a context, to trace modern configurations back through climate, tectonics, and ecology, and to carry that history into decisions about how to live responsibly on a planet that remains in motion. So the narration closes with a gentle insistence that is at once scientific and humanist. The study of Pangea is not only an exercise in reconstructing old maps, it is an apprenticeship in scale. It trains the mind to hold human ambition and geological patience in the same frame, to see how a rift valley becomes a river corridor, how buried organic matter becomes fuel, and how mountain roots shape rainfall patterns that guide migration and agriculture. To regard Pangea as merely ancient geology is to miss its more consequential role as the opening chapter of the modern Earth. It wrote the grammar that still composes planetary possibility. And so the listener is left with one last question, folded into the text like a bookmark. Do those who call this fragment of crust home truly understand the place they live if they have never peered back to when it was whole? The question is not accusatory, it is an invitation. To accept it is to begin reading the long narrative of landscapes, climates, and lives, a narrative that humbles and enlarges in equal measure, and that asks patience, curiosity, and a steady willingness to learn from the slow, secretive processes that made the world possible.